Good morning, everybody. On behalf of myself, Jacob and Prateep, we're really pleased to be able to welcome you to today's session, transitioning from vulnerable to resilient and viable fisheries, social-ecological systems. So we've got a great day full of really exciting talks, which I'm really looking forward to hearing about. And we also have a number of posters in the poster session tomorrow evening, which I also encourage you all to attend. We've got quite a tight ship to run today, so we don't have time for lots of in-depth discussion. So on Wednesday afternoon, we also have a session between 3:30 and 5:30. The details are in the schedule, but a discussion and networking event for further connection. So presenters, please stick to your time. I'll stand up and wave a piece of paper at you when you have 2 minutes left to present. And then we'll have a couple of minutes for questions from the audience and also from our online participants.
And our next speaker is Prateep, also session organizer from University of Waterloo. Thank you.
Okay, thank you very much, Jenny. That was a nice, background to the research that we all are doing together in different parts of the world. But I am going to take you into some of the understanding of vulnerability to resilient and viable small-scale fisheries or fisheries social-ecological systems, especially in the context of many changes that are taking place within these social-ecological systems that kind of co-host both human beings as fishes, but also the diversity of these ecosystems with multiplicity of species. So in some of the recent literature, and it includes some of our own explorations and analytical work, we have tried to look at what are some of the key sources of vulnerability. In this particular figure, you would see that the sources of vulnerability goes into domains of identity, domains of how people look at their loss of institutions, and the material and the subjective and the relational aspects of fishes' lives. And therefore, there is a very diverse context within which vulnerabilities do take place in small-scale fisheries socio-ecological systems. But there are also responses that in the second half of the table that you would see that people do engage in interacting with the vulnerability. Therefore, the prospect for moving towards viability is also very real. If you look at all those sources of vulnerability then, in fisheries socio-ecological systems, it tells us that vulnerability and viability are multidimensional. There is no one meaning, there is no one way to look at them, but there are multiple sources, therefore there are also multiple expositions of those vulnerabilities and viabilities. And that is mainly true in the context of small-scale fisheries because it is so diverse. Of course, to that particular explanation of this being multidimensional, if you look at vulnerability domains in the literature, you would see multiple ways of explaining and defining vulnerability that comes from different sources, and I'm not going to go into the details of that. Similarly, viability has many faces as well, and therefore both vulnerability and viability becomes multidimensional, complex, and multidirectional in many ways. The way we look at in our own work, and I will talk a little bit about the project that many of us are involved in, is not to look at vulnerability and viability just in an economic or an income or on a material sense, but also to look at social, political, ecological aspects of small-scale fisheries, and therefore to keep in tune with the narration that I started with, multidimensionality of small-scale fisheries. This is also looking at various other aspects of vulnerability and viability, and therefore it looks at multiple aspects of people's life. There are three ways we are trying to understand vulnerability and viability. One is by linking to the capital resources, and again, there could be material aspects, there could be non-material aspects, but if you look at the capital resources, can we understand vulnerability and viability by using these capital resources as a basis of vulnerability or viability? And therefore, we could conclude that vulnerability results from the lack of access to these capital resources. And they could be purely social, to material, to physical, and financial. But at the same time, capitals enable individuals to navigate circumstances of multiple changes, therefore gives the strength to the community to respond to vulnerability at the same time. The second way that we try to understand vulnerability is by interpreting it as an absence or presence of well-being. And well-being theory tells us that there could be material, there could be subjective, and there could be relational aspects of well-being, and the interactions between these three defines the true meaning of well-being in a society. So the material, relational, subjective dimensions of well-being, specifically the absence of any one or more of these types of well-being, creates different types of vulnerability in small-scale fisheries communities. The third aspect we use is the resilience, which is also a topic of this particular session. Building resilience is a way of dealing with vulnerability, therefore moving towards viability. And it is about responding to adversities, it is about responding to the many challenges, and it is about maintaining some kind of a status quo, but also the adaptive capacity to respond to vulnerabilities. So vulnerabilities come from loss of small-scale fisheries community resilience, and therefore reduced resilience could be equivalent to increased vulnerability and vice versa. In the literature, most of these vulnerability and viabilities discussions takes place in isolation from each other. People talk about vulnerabilities, people talk about viabilities. Seldom there is a connection between these two that have been established. In our work, what we have started to emphasize is it's not about important to only understand vulnerability or important to go about pursuing sustainability, resilience, or viability, but to see what makes the transition from vulnerability to viability possible, especially in small-scale fisheries communities. Therefore, the transition becomes the essence of the question, rather than focusing narrowly on either vulnerability or viability. Therefore, the transition from vulnerability to viability is a key research question that we are trying to focus. And we're trying to do that through a global partnership of small-scale fisheries, which is named as Vulnerability to Viability Global Partnership to build strong small-scale fisheries. And it has 4 objectives, that directly speaks to the transition or the possibilities of a transition from vulnerability to viability. The first one is, Jenny has also touched on that particular point of co-production and co-creation of the knowledge and the whole set of knowledge that can help us, make this transition possible in moving towards viability from vulnerability. The second one is, how do you manage the co-produced knowledge? Therefore, the focus is on developing an information system or a repository that can hold this co-produced knowledge, and therefore the processing of the knowledge would lead to mechanisms and processes to move from vulnerability to viability. The third one is the transdisciplinary capacity and the recognition of the existing capacity, or in other words, the types of capacity development that is required to make the transition from vulnerability to viability possible. And the fourth one is compare and synthesize and integrate the knowledge in multiple ways across multiple levels. Therefore, these transitions are supported with synthesized knowledge. We see this in this particular figure. So in order to move from vulnerability to viability and to make the transition possible, there are 5 domains of work. One is the knowledge that I talked about. The second is the types of capacity. The third one is mobilizing the knowledge. The fourth one is archive or repository or database creation. Therefore, one can synthesize and integrate the knowledge. And the fourth one is the fifth one is dissemination and mobilization of the knowledge. There is a particular conceptual and methodological framework that guides our work, and they happen in 4 domains. One is, of course, Jenny again referred to political ecology, gender and empowerment, the discursive elements that can guide this transition. The second one is interactive and multi-level governance processes. The third one is social-ecological resilience and adaptive capacity. And the fourth one is well-being, sustainable livelihoods, and similar development approaches. And our methodological approach is a case study that is place-based, that is comprehensive, that is inclusive, diverse, and dynamic. And this B2B global partnership exists in different parts of the world. Especially, we are focusing in Africa and Asia. 6 countries in Africa, as you can see in the map on my left here. 6 countries in Africa and 6 countries in Asia. We were doing the comprehensive case study to explore the B2B transition processes in more focused way. It is an integrative team of 121 scientists, practitioners, policy and community actors, 38 universities, 22 government and research institutions, 25 NGOs, 65 graduate students, and what we call high qualified personnel, including early researchers, and 26 countries, 6 continents, and it's growing because the membership is at this point growing. I want to leave this with 2 big questions. One is how to make such a process inclusive while keeping the diversity intact, because small-scale fisheries is very diverse, and the kinds of transition we are talking about is situated within the diversity that exists within the small-scale fisheries context. And the second one is how to further develop and let the B2B transition perspective evolve, because it's not vulnerability or viability that are important, but the transition from vulnerability to viability, which is the key question here. So we're further exploring this, and I'm happy to answer any questions if you have. Thank you.
Any questions for Prateep? You can also run the mic over if needed.
So we need to come to the very front to turn around and turn to the... Okay. It makes asking questions really easy. So thank you very much for the presentation, and I think that's a question maybe that goes to you as well as the former speaker, because you talk about co-creating knowledge. And in some of the contexts I've been working with your communities, this idea about co-creating knowledge is kind of challenging. And I think the speaker before talked about learning, mutual learning. And what was your experience in the whole process when you were working with communities about this, about this concept, this general concept? Because one of the ideas is, of course, to create that knowledge repository. But how is it perceived in the communities? Is it more like this, oh, we don't really know what's happening, what is co-produced, what is the knowledge that is co-produced, or is it really more about learning?
Yeah, thank you very much. So there's a lot of challenge in co-production. It's a contested term, so that's why, what we have started using is, the precursor to co-production of knowledge is knowledge recognition. Because there is a lot of knowledge that exists at multiple levels, at the community level, at the scientific level, but at the same time, if you don't start with the proper recognition of all these different types of knowledge, the co-production doesn't take place. So therefore, once you start to recognize and then bring these different knowledge domains together through a process-oriented approach, and Jenny spoke about it at length, then that leads to some kind of, and this could be very situated kind of knowledge, because you may have to co-produce the typical knowledge that is only beneficial and applicable to a particular context. So you cannot co-produce a knowledge for a larger social-ecological system, but you have to make it very contextualized. So given the contestations in sight, one needs to engage in that process of co-production. But there are multiple other terms that are being used to explain co-production and co-creation, knowledge sharing, adaptation to knowledge systems, knowledge as a discursive process. So we have to kind of engage with all those processes rather than just strictly being in knowledge co-production mode all the time. Thank you.
Thank you. Speaker is Olivia, who's going to talk about climate change risk and adaptation for our case study in Ghana.
Good afternoon. Thank you very much, everyone. My name is Olivia Harrod from CFAS in the UK. My presentation is about an ongoing project under the One Ocean Hub programme, working with partners from the University of Cape Coast in Ghana to assess climate change risk and adaptation options within their vulnerable fisheries. So just to provide some background on this work, the artisanal fisheries in Ghana account for more than half the country's food fish supply, as well as supporting the livelihoods of around 2 million people. And the total value of these fisheries is estimated to be about $1 billion a year. So because of this heavy reliance on fisheries, many of the stocks that are really important for the country are close to collapsing through overexploitation and through the impacts of climate change. The biggest portion of Ghana's landings are made up of the small pelagic species such as sardina and anchovies, which are currently severely overfished. And the collapse of these stocks could lead to a direct loss of employment, worsened food insecurity, and a risk of increased conflict between West African countries over these valuable resources. There's also plenty of foreign-owned industrial trawlers operating in the country, so overall the fisheries are at overcapacity at the moment. And the impacts of climate change are expected to have detrimental effects on fish as well as fishing activities in the region, partly by affecting the overall health and distributions of the species, also by putting further pressure on ecosystem response and resilience. Although the extent of these impacts to local fishing populations are dependent on the adaptive capacity of the fishing communities. And adaptive capacity can be defined as the ability of the system to modify itself in order to cope with an external stress. And in this study, along with a few others carried out in these regions, they found that generally adaptive capacity is quite low, predominantly due to a lack of understanding from fishers about how climate change impacts their fisheries. So because of this, they've previously tended to adopt reactive coping mechanisms rather than planning proactive adaptation measures. So for the aim of this work, we tried to address 3 key questions around climate risk to Ghana's fisheries based off of this IPCC risk assessment framework, to take into account climate change hazards, fish and their habitat sensitivity, and the socioeconomic vulnerability of different fishery sectors and regions. And by doing so, we can help those associated with the coastal fisheries of Ghana to prepare for the climate change associated challenges of the future, with a focus on making informed decisions about possible management measures. So for question 1, which was the species sensitivity assessment, we used 39 species that have recorded catches in Ghana from the FAO FishStat database in 2019. And then to find each of these species' vulnerabilities to climate change, we took information related to their biological traits and habitat preferences from a couple of online databases, and then assigned sensitivity scores for each of these individual traits, which included temperature tolerance, habitat specificity, population resilience, and also price, which we added in to indicate levels of targeting from fishers. So then for each of these components, we could allocate a scoring system of 1, which would be a low sensitivity or a high tolerance, and 4, which would be a high sensitivity or low tolerance to climate changes. And then by allocating an overall species sensitivity score, by taking the mean of these individuals, again, where 1 is a low sensitivity and 4 is a very high species sensitivity. So we found that the demersal species in Ghana are most highly sensitive to climate change, with an average overall score of 2.7, which gives them a high sensitivity. Particularly snappers, Congo dentex, and groupers, they all had the highest sensitivity of those we assessed. They all scored a 3.2, which would give them a very high species sensitivity. And this could be attributed to their limited distribution within coastal areas and their sedentary characteristics, which make them a somewhat easy target for fishers as well. And then we have the large pelagic species, which had the lowest overall sensitivity, with an average of 2.1, which gives them a medium. And of this group, it was some of the tunas and shark species that had the lowest scores. They all got below 1.8 due to their highly migratory behaviour and their ability to tolerate a wide range of temperatures. So they're able to move away from the areas as well that aren't suitable for them anymore. And then the middle species are classified as the small pelagics, and it's of this group that the European anchovy and round sardinella make up the biggest portion of Ghana's catches. And this group also had a medium average sensitivity of 2.1 due to their similar characteristics to the large pelagics, and they're also more mobile than the demersal species as well. So then we looked at the overall climate vulnerability for the 9 main fisheries sectors in Ghana, and this was done by combining the composition of the catches for each sector with the sensitivity scores from the previous slides. We normalised the risk across the 4 regions of Ghana's coast, across the fisheries sectors to give a vulnerability score between 0 and 1, where again, 1 is the greatest vulnerability. And the results of this highlighted the importance of the artisanal sector, which has significantly higher catches overall than the industrial sector, although it was the pelagic fisheries that had the lowest vulnerabilities due to their landings consisting of the less sensitive species like the round sardinella, horse mackerel and anchovy. And on the other hand, it was the artisanal sectors that had the highest vulnerabilities, most particularly the artisanal demersal Persane sector. They scored a 1, the highest score, as they are targeting really highly sensitive species such as the big-eye grunt. So then question 3, looking at the regional assessment. This was based on data of fisheries vulnerability, climate hazard and socioeconomic vulnerability. And for all of the metrics included in these components, the data was again normalised across Ghana's 4 coastal regions and given a mean score, where same as before, 0 is low risk and 1 is high risk. So the Volta region in the east showed the highest overall artisanal climate risk, driven mainly by the high wind speeds they experienced here, as well as overall quite high poverty levels. And alternate to this, Greater Accra, which is the region just west of Volta, had the lowest risk score, reflected by low socioeconomic vulnerability, as is generally seen in capital regions, as we've observed in previous similar studies as well. There is still a significant amount of risk here, though, and coastal flooding has been expressed as a particular concern by local communities in this region. So, by looking at the results from these 3 different assessments, we can start to think about what adaptation options could be used to address the specific aspects of the risks that we identified. And we're planning to follow this up by hosting an in-country workshop this year with a variety of Ghanaian stakeholders, where we're going to use this bow tie analysis method to identify any gaps in our knowledge and also identify any barriers to adaptation that we haven't yet thought of ourselves. And the results of this will then help us to develop an adaptation policy brief that we can use to communicate the options more effectively in the country. But from our current research, we found that the potential adaptation options need to be location-specific, taking into account the socioeconomic differences between regions and the differences between catches from the different sectors. There's a lack of understanding of these regional and sector-specific climate impacts could lead to maladaptation and worsening of the current situation if the wrong options are used. So on the regional scale, particularly the regions that are at risk from coastal flooding and storms, then climate-proof infrastructure is a good option, possibly, to help protect landing sites and roads, to minimise disruption to local fishing activity. So currently, regions that are at risk of flooding, like Volta and even Greater Accra, they lack the infrastructure at the moment to deal with the regular flooding that they experience. Other options could include market diversification, whereby promoting the targeting of less sensitive species, such as the tuna, could allow some of the overexploited demersal species to recover. So additional quota for landing fewer sensitive species could be allowed to help with this. But it's also important to consider not only moving away from the species that are sensitive to climate change, but also those that are already overfished and overexploited. So artisanal fishing fleets may wish to change their gear types to diversify their catches away from these species, rather than the typical behaviour of switching to a bigger boat so they can travel to more distant fishing grounds, which consumes more fuel and still maintains a lot of pressure on these overexploited species. And then other options to reduce vulnerability in these regions could include fishers seeking out different livelihood options in order to maintain an income. Not only the fishers that actually go to sea, but the construction of the canoes they use makes up a significant portion of employment in these regions as well. But it has been calculated that only around 9,100 canoes are actually needed in order to fish sustainably in Ghana. So to limit further canoe construction, agriculture could be a desirable option in the communities where the accessible land is available. But just a final note, it's really important that any of these options used, or any others I haven't mentioned, they need to be effective in the long term if they're going to tackle the combined effects of overexploitation, along with the impact of climate change and socioeconomic vulnerability. And to do so, increasing education around climate impacts to these local populations, as well as continuous monitoring of any measures in place, and so any continuous monitoring of these measures will be really important for ensuring that these communities can maintain sustainable income and food supply in the future. Okay, thank you.
Thank you so much. We have some time for questions.
Thank you. This is Tarubahri from FAO. I had a question about the forthcoming workshop that you're planning to hold. And in addition to identifying or informing about adaptation options, I was wondering whether you were planning to also collect some information on the local community's perception of climate change and how it has affected their livelihoods.
Yeah, I think when we do host the workshop, it will be really important to make sure that we can get opinions from as many people as possible, especially those fishers and the local communities. Not many plans in place at the moment for the workshop, but I'm hoping that we'll be able to involve a lot of different people with this.
Thank you. Great talk. My question is about the interaction between regulation and climate change and their impacts on fishing, because I know that Ghana's new fisheries management plan has a lot of regulations that would directly impact the kind of fisheries you're talking about, like reduced fishing days and gear restrictions. So my question was just whether you think that those restrictions will have overall positive outcomes, given what you've suggested about the sensitivity of the fishery species, or whether that's just going to add an additional pressure to those fisheries or fishing communities.
Yeah, I think it's difficult to say about that. I'm not entirely sure. I think it's just something else to consider. Hopefully, once we've had this workshop and we can get more opinions about what the local populations think about those restrictions, then we'll have a better idea then of how to manage them in the future.
Question back here.
I don't know if I have a voice. Oh, I'm Batman. I was surprised that you didn't mention anything about reducing access rights for Indigenous European fisheries in Ghana and that area as increased vulnerability. Could you speak more about that?
Yeah, again, not entirely sure how much we can recommend about restricting fisheries. I think a lot of the I mentioned about industrial trawlers operated by foreign countries. I think that's kind of a different issue in itself, and quite political possibly. We can only help adapt to climate change, really. Sorry.
No, that's good. Thank you so much, and thanks for all the questions. Hello, everybody, and hello, virtual participants. Hope everyone had a good lunch break or break. Our next speaker is Kathy Mills. She's our second invited speaker here to talk about climate change resilience, and I think even a little bit of the lobster case study, right? Perfect. As a reminder, if you can come up and get ready. If you're speaking next, please go in the back and get your headset set up while we're taking questions.
Well, thank you all for the excellent after-lunch turnout. Amazed that everyone made it into the room so promptly. So I am Kathy Mills from the Gulf of Maine Research Institute in Portland, Maine, and I'm going to be speaking today about some work I've been doing with a larger global working group on climate resilient fisheries and focusing on assessing and operationalizing climate resilience in marine fisheries. So I want to acknowledge that this is the work of many co-authors, including Jacob, who just introduced me, and Kristen Kleisner, who was here in the room earlier, and really a much broader group of people. We were part of a SNAP working group, the Science for Nature and People Partnership, which includes a number of people from around the world. So to give you a sense of the topics I'm going to cover today, I will start with an overview of just some highlights and global perspectives on climate change, oceans, and fisheries. And then I'll walk through sort of three major elements of this working group's work, looking at climate resilience attributes, how we've assessed those attributes in specific case studies, and then finally a framework that we've developed for supporting assessment and planning for climate resilience in marine fisheries. So I'm going to start with sort of a big picture place setting of climate change, the oceans, and how it's relevant to fisheries, just really highlighting that there has been a ton of work that has come together recently. A lot of it's come out through the IPCC, but also a lot of independent studies. And the IPCC has essentially published three reports recently focused on the physical basis of climate change, impacts and adaptation, as well as mitigation. And just to highlight some of the messages we're hearing loud and clear as we see these reports come out and be synthesized, we're hearing messages that it is virtually certain that the global ocean has warmed unabated since 1970, and that it's taken up more than 90% of the heat in the climate system. And since 1993, the rate of ocean warming has more than doubled. And we're also experiencing more frequent and longer duration marine heat waves. So many changes occurring, and they're occurring at magnitudes that are no longer something that you can dismiss or ignore. We're seeing the impacts of the physical changes in the ocean play out across marine ecosystems, affecting basic, biogeochemical processes, ecological processes and interactions, as well as the services that we derive from the oceans. And these changes all affect our ability to achieve societal goals, whether they be set or important at local levels or at global scales. As we look ahead, we expect there to be continued changes that play out in the oceans and biological systems within them. This is just one figure of a projection of benthic animal biomass and fish biomass across the oceans under two warming scenarios, a higher mitigation scenario and a lower mitigation scenario. And what you see is a lot of pink when you see these maps. And the pink essentially means we are projecting declines in species or declines in the biomass of fish and benthic animals. And obviously the amount of pink differs across the map. So you see less pink in the top row and more pink in the bottom row, indicating that our choices about carbon emissions have a big effect on what the future might look like for the oceans and for fisheries that depend on marine resources. So the Climate Resilient Fisheries Working Group developed within the context of this awareness to try to think about how we can sort of prepare and be more resilient within the marine fisheries realm to these changes that are occurring and that are expected to continue developing and progressing over time. So the group focused on three main questions. The first was, what key features may make fisheries more resilient to the effects of climate change? What approaches and tools can confer climate resilience in fishery systems? And how can practitioners diagnose system resilience and identify strategies to support it and achieve goals that they're trying to accomplish in their programs? So we stepped through these 3 questions with an approach that went from sort of theoretical to very practical applications. We started with a working definition of resilience and did a literature review to identify attributes of resilience across a suite of social ecological system types. We then used those attributes to analyze how they play out in specific fishery cases and kind of what they look like in aggregate within and across cases. And finally developed a framework or decision support tool to support resilience assessment and planning in marine fisheries. I'm going to walk through all of these steps today just very briefly, but the first step was to establish a working definition and identify attributes of climate resilience that support marine fisheries. So the definition that we adopted in this group was quite broad, viewing resilience as multifaceted, the capacity of a system essentially to withstand, recover, adapt, or transform in response to a change. And we were really interested in also taking a broad view of how resilience might come into play in fisheries. So we considered multiple dimensions of resilience, looking at ecological, socioeconomic, and governance dimensions of fishery systems and attributes within each of those that may support climate resilience. You've already seen the framework that comes out of Josh Sinner's work presented in some of the earlier talks today, but we use this as a heuristic just to organize attributes that we were extracting through this literature review into major categories related to assets, flexibility, organization, learning, and agency. And from this work, we identified 38 individual climate resilience attributes spanning ecological, socioeconomic, and governance dimensions of fishery systems. This is published, if you're interested in digging in deeper, in a paper that Julia Mason, who's also here, led along with Jacob and Jackie Lau, as well as other members of the working group. But essentially, we extracted these attributes. We tried to establish definitions that synthesize their meaning across multiple studies that they came from, and also tried to articulate the mechanism by which we could see them influencing climate resilience in marine fisheries based on the published literature we were drawing them from. And we recognized that resilience is contextual. So there's a number of contextual considerations that are also important to bring into consideration. And those are highlighted here in the blue box that, essentially the resource status and history, power structure within a fishery, market or institutional incentives, those types of elements will also influence the potential for attributes to emerge and for resilience to be developed within a fishery. So I'm going to move now into the second 2 steps and treat these together in this presentation to look at how we looked for these attributes in specific fishery case studies and used information from across the attributes to assess resilience in different fisheries. So we developed case studies for 18 fisheries around the world. The selection of cases was really influenced by the expertise of members of the working group, as well as the availability of literature and some background information to draw from. But we tried to work across a variety of different types of fisheries and a variety of different geographies. And so I'll give you a little bit of an overview of what we covered, but really Jacob is going to be covering this in a talk on Friday in much more detail. And Kanae Tokunaga, who's speaking right after me, will be covering some of the learning attributes from these case studies and how they emerge in different fisheries. So essentially, when we developed case studies for specific fisheries, we used a standard rubric that we also developed to pull out specific information in a consistent manner across these fishery cases. This enabled us to capture the contextual information that's relevant to the fishery, some of the past events and stressors that provided us with information through which we could evaluate resilience attributes, and some of the actions that had already been taken to promote resilience in particular fisheries. And really a core part of this case study work was to rate the score the importance and the data quality for each of the 38 attributes that we had extracted in the literature review. So we worked through each of those in these cases, and I'm just going to highlight what some of that looked like for the case study that I was responsible for that focused on the Maine lobster fishery. So the Maine lobster fishery is, or the lobster fishery in the US is the most valuable single species fishery in the country. And in the state of Maine, it's an incredibly important fishery. It represents about 80% of all of our total marine fishery landings in terms of value. And for much of our coastline, Maine has a very long coastline, and I would say about 80% of it is very rural and very dependent on resource-based economies, and fisheries are a huge part of that economic base. So there's high importance and high dependence on this fishery in the state of Maine. And Kat will also have a poster on this in the poster session to go into greater depth about some of the work we've been doing on social resilience in the lobster fishery. So the Maine lobster fishery occurs in an ecosystem that is warming rapidly. The northeast shelf of the United States has been warming about 2.5 times faster than the global average warming rates for oceans across the world. And in conjunction with this warming, we're seeing contrasting experiences for our different lobster populations in the region. So the Maine fishery is dependent on the Gulf of Maine lobster population, which has been increasing as warming has occurred, while the southern New England region, which is a bit further south, has actually been declining since the mid-1990s. And we've done some modeling work to look at the influence of temperature on these changes, and we can attribute this to temperature, or we can attribute a large portion of this change to temperature. So what we did in the modeling work was essentially flip the temperature experiences for the lobster population in a certain region and look at what would have happened if it had held a constant average temperature over the whole time period versus if the temperature had actually increased as it did in reality. And essentially what this is showing is that the Gulf of Maine lobster population follows the blue trend, or the blue temperatures, which are the actual temperatures. So the warming we've experienced in the Gulf of Maine has actually enhanced growth of this population relative to where we would have expected it to be under average temperatures. In contrast, in southern New England, it also follows the actual temperatures and reflects a detrimental effect of warming. It would have been at higher population levels if it had not experienced the warming that occurred. We've also experienced marine heat waves that have affected this fishery, particularly one in 2012, where it spanned, really warm temperatures spanning the northeast shelf all the way up into the Labrador Sea and over to Iceland. And since that time, the heat waves are shown in this figure in the black bars. So this is 2012, where we had a heat wave for much of the year, but you see that there's a lot more heat waves occurring since 2012 than we were experiencing prior. And this had major implications for the lobster fishery and provided an interesting opportunity to really look at stressors affecting this fishery and how social and governance dimensions held up against this stressor. So we experienced warming very early in the spring that led to an early onset of high landings for the fishery. But those collided with a supply chain that just wasn't ready for that volume of landings and for having them come in at that time, and ultimately led to a price collapse that year where we saw prices drop below the lowest point that we had seen since we had been collecting data. So I want to pull out for the lobster fishery some of the attributes that we identified in our review and look at how they influence this fishery. So one of the attributes that we extracted from the literature review as supporting the ecological dimension of resilience was population abundance. And what we see in the lobster fishery is that warming has enhanced population abundance, has also enhanced recruitment. And that high population abundance has supported a growth in fishery landings. So the fishery has benefited from recent warming. We're not looking ahead to future projections, which do indicate that we should expect a downturn, that they will become detrimental to the continued growth of this population. In terms of socioeconomic attributes, one attribute that comes into play and is important in this fishery is a general resilience mindset. So the industry itself has actually been conducting several conservation measures, some of which have been in place for more than a century. And these were really industry-led measures to recognize that they wanted to be able to sustain the stock long term. So one of the important measures is that when they catch a buried female, a female with eggs, they cut a notch into the tail of that lobster so that another lobsterman who might catch that will know that it's a female and should be returned to the ocean, even if it's not bearing eggs at that point. And they also have size limitations on what they harvest. So there's a minimum size limit as well as a maximum size limit where they are ensuring they are not harvesting small lobsters before they get to a reproductive size. So these measures have been in place for a long time, were industry-led, reflecting a resilience commitment from the industry itself, and have supported population growth. And also place attachment is really important in this fishery. Along the coast of Maine, the lobster fishery is actually regulated and managed by zones that are attached to certain portions of the coastline. So lobstermen can only harvest from certain zones that they are attached to, but also the zones have a major role in terms of elevating voices from the harvesters in that zone up into the management system. So there are zone councils attached to each of these areas as well, where they raise concerns and address issues facing the fishery within those councils, and that can then get consolidated to a statewide level. And this intersects with the governance dimension, where this feature is contributing to a polycentric governance structure that we identified as one other attribute that should support climate resilience in fisheries. So I mentioned how the zones can elevate concerns and approaches that they would like to see adopted. To the state and zones really work in a co-management arrangement to then take that information up to a multi-state commission, the Atlantic States Marine Fisheries Commission, to propose management measures and to eventually choose which management measures to adopt. So those are some insights into how attributes were identified and how we looked at them within individual fisheries. But then we've also synthesized this information across all of the cases that we examined. And this, again, will be part of Jacob's talk on Friday, so I really encourage you to attend that. But I think some of the interesting features of this synthesis is that we were able to identify 5 different typologies across the 18 cases that we looked at that really fall out along lines of how resilience is supported across the 3 major dimensions of fishery systems that we examined. So there are some fisheries in which resilience can emerge, even if you have only strengths in certain areas, and other fisheries in which you see resilience really emerge from characteristics across all 3 of those dimensions. And then one other element of this paper is that we also identified distinct pathways through which the dimensions kind of interact with each other across these cases. And then our final portion of work for this project, we attempted to bring this information together and develop a planning tool that would support decisions and efforts to enhance resilience in marine fisheries that could be hopefully useful for taking this approach out to many different cases and fishery systems. So we published the Climate Resilient Fisheries Planning Tool in late January, and you too can go there and visit and dig into and play around with this tool. It's at climateresilientfisheries.net, and it essentially lays out a 6-step process for assessing a fishery's climate resilience and identifying approaches that can help support resilience in those fisheries. So the 6 steps include elements related to defining the fishery system. What do you want to include in this assessment? How are you going to bound the system of analysis? And thinking about long-term goals that are the intentional focus of the assessment and planning process. The second 2 elements relate to assessing the system, and those include assessing climate impacts and potential changes expected in the fishery, and evaluating climate resilience attributes. And then the last phase relates to planning for the future of the fishery, brainstorming climate resilience actions, and then identifying and prioritizing pieces that could be moved forward or potential timelines for moving those forward. So just to give you a sense of what some of the pieces of each element look like, one of the really important questions that we confronted in working through the case studies is, what are the bounds on a fishery system where you're not necessarily just interested in the harvest sector? You might be interested in how the harvest sector intersects with the supply chain, but often you're interested in how it intersects with communities, and where do you draw those lines? And that was really important in each of our cases for each author to bound their system in an appropriate manner. And so we start this process by laying out information on system maps so that can support discussions around what is going to come into the assessment and what is going to have to be left out and perhaps, you know, put into the parking lot for a later effort. We also provide some information related to how to think about potential climate impacts, as well as recognizing that climate is not acting in isolation of other stressors. And so really thinking about the multiple stressors in a system and which ones are being influenced and modified because of climate change. And then we provide a framework for working through an assessment of the climate resilience attributes that we identified in the literature review. I mentioned that we started with 38. We've sort of scaled those back to 22 that we saw that were consistently important across the case study work that we did, because going through and thinking about 38 attributes is really daunting for most people. 22 is still quite large. And so this is a space where we do intend to gain experience using this tool in other situations, and we'll continue refining this as we move forward as well. And ultimately, depending on how you populate the ratings for those different attributes within a fishery, we provide a way of categorizing those to understand which ones might be important and how are they scoring right now in the current conditions of a fishery. So each attribute, you may have a certain feature that is very well represented in a fishery system. Population abundance might be one example that I used in the lobster fishery case, and that may or may not be important for resilience in that fishery system. So in this case, I think that would be important, but we may have rated another attribute like perhaps genetic diversity that's also well represented in the fishery system as being less immediately important to conditions the system is facing right now, but may become more important later. So this is a snapshot, and we do advise that this would be beneficial to iterate through and use multiple times in an ongoing assessment approach rather than one time put it aside and leave it behind. And we also, in the final portion of this framework, encourage its use to brainstorm potential actions to both address fishery impacts of climate change and also to build and enhance attributes that could support climate resilience in the fishery system. And we provide just very general guidance on this to leave this really up to the users to structure for themselves, but we do provide some ideas of potential strategies, like for addressing fishery impacts. If one of the big impacts is changing catch levels due to stocks shifting their distributions, thinking about structures for access to those stocks. And then also thinking about how to build and enhance certain resilience attributes. We provide some examples, but not a prescribed path for how to do that. So just to wrap up, I want to summarize by reiterating the point that resilience really is a multidimensional feature of fishery systems. It can be supported across all of those dimensions. It doesn't require that one certain element be the focus of all efforts to prepare for and be resilient to climate change. And that there are win-win strategies for climate-specific resilience as well as general resilience in fishery systems. It's important to recognize that climate change is also operating with multiple other stressors in most of our fisheries and with ongoing changes that are occurring completely outside of the climate realm. and considering how fisheries fit into cross-sectoral planning efforts can be really important. And as I mentioned, we feel like the approach to assessing resilience and thinking about strategies is best operationalized as an iterative process, because resilience is a process rather than a state. In the way we're envisioning, with ongoing climate change, the situation will constantly keep changing. And then I just want to also point out that transforming is part of our resilience definition, and as such, it provides an avenue to think about opportunities for how to use climate resilience planning processes to also achieve broader goals that might be related to very different interests, like how power is shared in efforts to manage our fisheries, and the equitability of different solutions that we attempt to move forward. So we are going to be trying to carry this work forward through an Ocean Decade program called FishScore, Fisheries Strategies for Changing Oceans and Resilient Ecosystems. Through this work, we intend to establish an international network of partners, collaborators, and just people who are generally interested in sharing the opportunity to learn about climate resilience and thinking about information and tools for resilience assessment and planning. We'll then also be trying to build collaborations with scientists and practitioners in other fishery systems, in more local fisheries, to be able to sort of establish feedbacks and scale this work across global to local and regional applications. So if you're interested in learning more about FishScore, please see me or Kristen Kleisner, Kat, or Jacob, or Kanae, all of whom you're kind of seeing in this session. We'd love to talk more about that. So I'm going to end there and just want to recognize that this is work of many, many different collaborators. I tried to capture the folks from the SNAP Working Group who I think are at this meeting. And work on the Maine lobster fishery has also been done in collaboration with Kat and Lisa Colburn, who are here. And with that, I would be happy to take questions if there's time. Thank you.
Thank you very much, Dr. Mills. Maybe there's time for just one quick question. Yes, I don't know. How do I take it out? We need the mic for our own. Yeah, I just needed to pull it out.
Thank you. So my question is, I know this is an iterative tool, but understanding that the lobster industry in New England is so heavily regulated, and that you were working with the Atlantic States Marine Fisheries Commission. Mm-hmm. Has the Atlantic States Marine Fisheries Commission and the New England Council, do you know if they're going to use this tool in some of their stock assessments, and if they are, will they provide some feedback in what way they might have used it to?
Yeah, I think it's too early to know. We just released this in January, and so we are still, there is, I would say, interest at the state level in terms of what the future resilience of the fishery will look like, and substantial concerns about what this might mean for fishing communities along the coast. And so I could definitely see uptake and integration of this into some of their work, and I'm talking with people at the state level. Beyond that, I think, it's not necessarily designed to fit into a stock assessment process, but it is designed to give you a broader perspective on that fishery system, which then might influence the management measures you choose coming out of a stock assessment process.
Thank you very much. That was great. Our next speaker is Kanae Tokunaga, and the title of her presentation is Understanding the Roles of Knowledge and Learning in Climate Resilient Fisheries.
All right, good afternoon, everyone. And the presentation is directly related to what Kathy just presented. But I'm going to go dig deeper into knowledge and learning attributes. So my co-authors are listed here, but when we worked on the first attributes paper, defining attributes of climate resilient fisheries, Lily and I were in charge of socioeconomic attributes. When we started thinking about how knowledge and learning related attributes play in climate resilience, we thought, well, it's really hard because we know these are important attributes, but we don't know how they are operationalized. And we did our best, reading the literature and trying to define them. And then we identify adaptive governance, knowledge diversity, so the diversity of knowledge sources, and access to knowledge and learning capacity as important attributes. But if you start reading the definition, you might think, well, so what does it really mean? So for instance, the learning capacity is defined as the degree to which individuals and communities are able to perceive risk, learn from experience, synthesize information, and grow their own knowledge. That sounds great, but there's a lot in there. So we really felt that we need to dig a little deeper, try to understand what they really mean. So that's what we did. So the same map that Kathy showed earlier in a slightly different format. But we had 18 case studies representing both small-scale fisheries, large-scale fisheries. There are multi-species fisheries, single-species fisheries. There are also different degrees of the information, the scientific information. So some fisheries are more data limited, and other fisheries are data rich or with really robust scientific information. So we thought this is a great platform to learn more. And then if you go to that QR code, you can go read the case studies that we developed through the tool that Kathy just mentioned. So each case study consists of two sets of information. One is the case study rubric that captures the climate resilient, the resilience attributes information, along with other information such as resilience actions, so capacity to improve climate resilience. Those information captures what are the types of shocks that they incurred in the past, and how they learn from those experiences. And case study narrative provides a really good in-depth or the contextual and qualitative description of how each fishery operates, and how and describes how different attributes work together to build climate resilient fisheries. So we relied on these information to do the learning attributes, to understand how learning and knowledge attributes are operationalized. So our research question again was, how are these learning attributes operationalized in practice? We wanted to gain some mechanistic understanding of how they work. And we looked into how the roles of learning attributes in each fishery, and how different fisheries integrate different types of knowledge into their to operate their fishery. We also looked into how other attributes contribute to the knowledge and learning related attributes. But today we're going to focus on the first two, but I'd be happy to talk more about the third component, the third research question after this presentation. But before I share the findings, I also wanted to kind of present where we went to kind of gain some theoretical, conceptual understanding of how knowledge and learning works. And we relied on the learning science literature, and especially looking at community science literacy. And then this quote is taken from the US National Academy of Science, the issue that talked about the science literacy, and it says that science literacy in a community does not require each individual to attain a particular threshold of knowledge, skills, and abilities. Rather, it is a matter of a community having sufficient shared resources that are distributed and organized in such a way that the varying abilities of community members work in concert to contribute to the community's overall well-being. It really, I think, is what we heard in the earlier presentations from this morning. when the community makes a decision on action, it needs to be situated in the community. And when we dig deeper into the learning science literature, it says that the literacy has builds on 3 domains: material domain, cognitive domain, and social domain. Material meaning, in our fisheries case, is the information or science or the data products that are presented to the community. Cognitive domain is pretty much what's in their head, what they know. But again, the social component is really important. And what that means is that all the information that, for instance, scientists are presenting needs to be reconstructed and be understood and then by themselves. So science information does not live in isolation of other lived experiences or their knowledge, existing knowledge. So this is a framework that we kind of relied on. And what we found is that the important thing, so we understood, is that how the knowledge is shared, the different types of knowledge are shared. And we looked into different cases, and we identified 3 general types. The first is kind of interesting, science-led process. So many fisheries that have robust science or more structured, formalized institutions, science process actually helps stakeholders share their knowledge and exchange information. Scientists sometimes play the role of knowledge broker to the diverse audience. And in this case, the knowledge sharing is somewhat like designed process. So they encounter different types of, they encounter new phenomena. So for instance, marine heat waves, they would hold workshops to understand what's going on, and then by inviting multiple stakeholders. So that's one kind of way that the knowledge sharing works in fisheries. The second is more harvester-led or customary, the fisheries that the knowledge sharing occurs as a customary process. So the harvesters may be as a daily routine meeting at the dock and then talking to each other and sharing what they're observing. Or they might be talking to their peers elsewhere to cross-exchange like what's happening in their waters with others who's operating farther away. And in some cases, these knowledge sharing is really built into the adaptive governance. If the fisheries is managed with the customary rules, then they're really good at responding to what they're observing because they have the daily routine of exchanging information as they encounter different environmental conditions. They are able to quickly exchange information and come up with a response. So it's a really responsive process. The third one is kind of interesting. So there are many fisheries, several fisheries in our case studies that had like integrated market system or supply chains really highly vertically integrated. And in those cases, harvesters exchanging information with their dealers, processors, distributors, and then they might be exchanging information and knowledge that way. And a market system, because if you're the seller of the seafood products, they know what's going on in the water, so they're able to kind of respond to that change more quickly. And how these fisheries were impacted by different types of shocks in the past. Our case studies had already experienced different kinds of shocks, from overfishing and resource depletion in the past to oil spills. Ocean warming is some fisheries already feeling through marine heat waves and things like that. And then there are some fisheries that experienced financial crisis. And I just wanted to highlight two examples. One is overfishing. They responded in the past by enhancing management. And in some fisheries, they made the TAC, more flexible. So that's one way. Another way might be diversifying target species, diversifying supply chain, diversifying market. Another example I wanted to share was regime shift and ocean warming. Again, they use the ways to respond to these shocks are diverse, and then there are different ways to respond to them, and then they've done that in the past. So this is the final slide. I wanted to kind of bring all back together and then try to connect with what the learning scientists are saying when it comes to how knowledge and learning works, which is that our characterization of knowledge, access, and diversity, they fits nicely to material and cognitive domain. And adaptive governance, which was another learning attributes, exist by those knowledge being shared within the communities and understood and responding, and those can lead to adaptive governance. There are also instances where the management structure is so inflexible and complex. But in those cases, individual harvesters or the individual participant in a fishery could be resilient by showing autonomous adaptation, so they can diversify their market. They can take different approaches, but again, those needs to be supported by other attributes. So in order for the autonomous adaptation to be activated, you might need certain wealth and reserve to be able to act on their plan, and then also agency is a key one that kind of supports how the knowledge to be activated in practice to achieve resilience and well-being. So that's it, and thank you very much, and yeah. Thank you.
Thank you very much. We just have time for one maybe question for Jenny.
Yes, thank you very much. So my question is that, you made this distinction between science-led, designed, and harvester-led, which you said customary. Mm-hmm. But my only apprehension or concern is that in this kind of, even the definition, if I remember properly, of NAS, National Academy of Sciences. So what happens is that I see somehow that, the sacrosanct division between exact and non-exact sciences, which is still a very dominant Eurocentric tradition, which unfortunately did not recognize much of the pre-Western, pre-modern, scientific practices as quote-unquote science, still, getting reflected here, and somehow giving some legitimacy to that kind of an understanding where we don't see, these practices. Some of the sciences actually evolved as part of the material needs of the society.
Yeah.
But so can you please?
Yeah, so we found that 14 out of the 18 cases said that they use both scientific knowledge and other types of knowledge, including indigenous and local knowledge, to make those are contributing factors to climate resilience. And to your question, the categorization that I showed, the 3 types, those are kind of how the process that are existent in the case studies that we reviewed. And those are not mutually exclusive to each other. Some systems utilizes multiple processes. And in one case, there was an interesting thing that was, the narrative was saying, which is that Western scientists wanted observation and climate change related research versus local residents or communities wanted to understand pollution impacts, chronic environmental challenges. There is a diverse, a different interest, and that didn't quite lead, they had diverse understanding, but without cohesive kind of communication would not contribute to the resilience. So I think, I'm not sure if it's not a direct answer, but it's a lot of nuance, and I think it's a really important topic that I think we can start bringing in like experts in the learning science field to really help us understand this better.
Yeah, that definitely needs more time to discuss, but you can catch during the coffee break. Maybe we'll move on in the interest of time. So the next speaker is Gavin Fay, and they're going to talk about linking fishery ecosystem models with indicators of coastal community well-being in northeast US. Gavin. Sorry? Oh, they're remote. Oh, okay. So next speaker is remote. Okay.
Hello, everyone. Sorry I can't be with you in Bergen today, but I hope everyone's enjoying the conference. My name is Gavin Fay, and we'll talk about some work that we're starting to do to link the output of a strategic fishery ecosystem model for the Northeast US to some social vulnerability indicators. But I think that one of the main reasons that we are interested in representing socio-environmental systems is because we want to appreciate the complexity of these coupled systems, and that there are interactions and links among the things within these systems that we're interested in, whether those be our sort of natural ecosystem services, but also the complex tapestry of our human communities and governance institutions. I think ecosystem models are kind of a well-used tool to sort of do some storytelling in terms of trying to understand how choices and assumptions we make for how we think about putting systems together and how the components are related, you know, how that can translate to things that we're interested in, such as fishery yield or biodiversity or dollars, jobs, things like that. So an example is the Atlantis ecosystem model and application of that for the Northeast US, which is a spatially explicit marine ecosystem model, which integrates lots of data to sort of project the dynamics of the ocean environment and the consequences of that for the food webs, and then trickling through to fisheries and indeed other human uses. We, in some work a few years ago, connected the output of our Northeast US Atlantis model to a regional economic model for the Northeast US as a way of trying to understand how changes in fishery yield from scenarios run in the Atlantis model would translate through to sort of the regional economy in terms of sort of taking the seafood sector revenue and translating that to supporting industries. So we can start to see how differences within the system are manifest for a wide range of socioeconomic indicators and goals. I think it's fairly common to summarize the results of these types of experiments with sort of aggregate indicators of performance, whether that be in relation to catch or employment or average income or total biomass or fish diversity. What we find, and I think in some cases what we did in this paper a few years ago, we did some relatively simple manipulations in terms of fishing scenarios, one where we increased the fishing effort over base levels, or where we decreased, and we sort of see these, at the aggregate level, we sort of start to see some fairly predictable responses. But when you disaggregate some of those indicators, say in this case on the right here into, we're looking at the income and the employment, but we're disaggregating it by fleet fishing sector, you see wide range of responses. So what you'll probably notice here is that those bars are not all the same. We have, some that are above above the dotted line, some that are below. And there's a wide range of responses for a given value, even though we sort of have this general trend of decrease income, say, for the reduced effort scenario to increase for the increased effort scenario. You get this, get these variable outcomes when you start breaking things down. And I think that's really important because we know that our communities are also going to be heterogeneous. So the impact of system changes clearly are not uniformly distributed, and that's going to have implications for our coastal communities. An example might be changing species availability to individual fishing communities. This is from Lauren Rogers' paper from a few years ago, looking at how shifting habitats in fish species due to climate change will impact the quantity of habitat that's available to individual fishing communities on the US Atlantic coast. And we see sort of different types of responses based on, for different species. Example on the bottom right here for monkfish, you clearly see that some communities will see a reduction in the amount of habitat that's available to them, and some communities will see an increase. Even in the Atlantic cod case, where pretty much every community sees a decrease, you notice that there's a large variability and uncertainty. So I think that's really going to be critical to sort of think about in terms of our coastal communities, because it's not just going to be changes, non-uniform changes in species availability, but we have non-uniform constraints related to fisheries regulation changes, perhaps market demands, or other types of changes that will be both local and regional as well. We're fortunate in the US to have a fantastic set of social indicators for coastal communities that describe aspects of pretty much every community within the country. Here focusing on New England communities and the North and the Mid-Atlantic, referenced in the New England State of the Ecosystem report by our colleagues at NOAA Fisheries. One of the things that they've been able to do recently is add to this portfolio a set of indicators that track metrics that we believe are going to be associated with environmental justice vulnerability for these communities. So we have several of the top fishing communities in New England that score highly on these metrics, so high in poverty index. They have large proportions of their population that are considered vulnerable, and they may have low education or low unemployment, and other factors that perhaps might suggest that those communities would be more likely to suffer negative consequences from changes. So those indicators can describe communities both in terms of the amount of engagement in fishing, so that's on the right, and also the reliance of the community in fishing. So we have in New England, we have a range of communities that rely on this within this two axes. For example, you might have, you have a place like New Bedford, which is very heavily engaged in fishing, but is less, the economy is less reliant on that fishing. The communities in red are communities that score highly on those environmental justice vulnerability indicators that from the previous slide. So the question is whether we sort of quantify those aspects of those communities, but can we sort of say, okay, well, we can use our ecosystem models to run scenarios to think about the consequences of alternative fishery management or alternative climate scenarios. Task now is to say, okay, can we map those expected changes from the ecosystem model to those indicators that we describe that are sort of summarizing possibly expected responses of those communities to socioeconomic change. So that's what I did. We sort of took the same scenarios that I showed before, the doubling of effort and the halving effort, so very simple fishing scenarios, and tracked them back, mapped the change in fishery landings at the port level relative to the base scenario. And then, place that on the fishing engagement, with the fishing engagement. So the fishing engagement index is on the x-axis here. So we have very highly engaged communities like New Bedford on the right there. And then the percentage change in landings from the Atlantis scenario is on the left for the two different scenarios. The larger the points and the labels, the higher those communities score on personal disruption index, which is a metric that tries to capture unemployment status and educational attainment and poverty. Basically, a high score on this metric sort of suggests that the communities have less personal capacity to adapt to changes, so they may be more vulnerable, which suggests that perhaps a percentage change in the same sort of percentage change in expected landings may have a more deleterious effect on a community that has a higher vulnerability, a higher personal disruption index than one that has a lower index, even if the other things are the same. We can do that same plot for the commercial fishing reliance. So the high reliant communities, you can see that we have increases and decreases for the two scenarios, and that some of that, communities that have high personal disruption are among those that have the most negative changes in percentage landing under the reduced effort. And they also may be potential winners in a fishing scenario that perhaps provided opportunity for fishing on additional species or things that might become more abundant as other stocks are being fished. And so that there's a lot to sort of disentangle here in trying to understand, what are the changes for the various fishing scenarios that manifest themselves in terms of changing availability of species to individual ports and communities. But I think this is a good first step in terms of trying to be able to sort of visualize how the possible sort of outcomes of, fishery ecosystem scenarios might pan out and might be able to be summarized in a way that sort of goes beyond perhaps just thinking about fisheries yield or biomass and conservation or even just revenue. So there's certainly room for improvement in describing how we're sort of doing this linkaging. The mapping of the ports in the ecosystem model to the economic model is very simplistic this time. In fact, we've just got some funding for a couple of different projects to sort of expand some of this. I think the next steps are going to be to create some real sort of spatially explicit fishing footprints within the Atlantis scenarios, which will sort of better track how infrastructure along the coast is, mapped to fishing at sea. And then we're also going to be doing some sort of management scenario testing using both the Atlantis model and some additional models that we're developing to sort of think about what are the trade-offs for different fisheries management options. Thanks very much, and I look forward to connecting you on Hoover.
Thank you very much. Maybe we have time for a very quick question if anybody has a question. If not, then we'll move on to our last speaker.
Well, so welcome back, everyone. Thanks for coming and sticking with this session. We've still got 6 amazing talks to hear from. So I'm just going to start things off. Oh, no, wait. If you're a presenter, just so you know, you need to go and grab a headset from the people in the back. So do that when the speaker before you is answering their questions. So with that, I'd like to welcome Rebecca Selden to the stage. She's going to be talking about distinct patterns in historical mobility and catch flexibility _ intraport variation in potential adaptive capacity to climate change.
Sorry for the long title. Just got excited about putting all my results in there. Well, thank you so much for having me, and this has been a great session. Excited to share this work that I've been doing with colleagues at Rutgers University that really is this interdisciplinary group of geographers and human ecologists to think about these adaptation strategies. All right, obviously no one in this room needs to sort of get this introduction where we know that marine species are shifting with climate change. In the case of the Northeast, poleward as the waters have been warming, and we've got some cooling effects, at least at some points on the West Coast. When we look at the projections over the end of century, however, we see more sort of uniform responses. Everything is moving north, but at different rates. And so given sort of what we're expecting for the future, we need to think about how these communities have adapted to past change and whether that can actually help us understand how they might adapt to future change. All right, so if we focus in on the Northeast US, looking specifically at an important fishery species, here I'm showing you fluke or summer flounder, which was focused off of Virginia and the sort of North Carolina region early in the time series in the 1970s. And by the sort of the early 2010s, it actually was focused off of New York and New Jersey. And so for those who might not have an idea of that scale, it's actually like about 300 kilometers north of where it used to be. And so if you think about fishers that might have been in North Carolina or Virginia, that's a long distance to try to follow this fish. So how have groups actually been able to respond to something like this? So you can probably think in your head of a couple different ways that fishers might respond. We could have them following the fish, that 300 kilometers north. We could have them staying in their traditional fishing grounds and switching what they catch. And as I think Elena Oheo's group had shown, they can leave the fishery. Many sort of other constraints sort of drive whether or not which of these strategies they might choose. So they're not free to necessarily decide which they do. So for example, following the fish, they might be limited by regulations that don't let them use that gear in that other region, or maybe forced to return to home port to land, which has other fuel costs, et cetera. They may want to switch to a new species, but that might mean they're switching to something unknown to them in terms of local ecological knowledge, or it might be unmarketable. So those are other constraints on that. In trying to think about future behavior, the scientific community has often assumed that either the fishing grounds don't move, so we look at what's happening, sort of how availability is changing if we just think they're static, or that they're only going to catch historical species, so not really allowing catch switching, or perfect switching to match availability. And so those obviously sometimes are simplifying assumptions we have to make, but we really want to know what responses do we actually observe, and what is that their demonstrated capacity for those changes that might inform how they might do so in the future. All right, so we first looked at this, so I'm not looking at leaving the fishery, I'm just focusing on the first two. We first look at this with focal trawl communities in the Northeast. So there were 12 with the little black dots from Beaufort, North Carolina up to Maine, and we looked at these two strategies, following the fish or stay and switching what they catch. We found that following the fish was actually quite rare and limited to those vessels that were large and those that were targeting a high value species where making that extra distance was worth it. So it was those summer flounder guys that were doing that. Instead, the more dominant strategy was switching what they catch. And we saw lots of different ways that they did that. Sometimes it was opportunistic catch switching. Other times it was selective targeting of a high value species like fluke coming into their fishing grounds. Other times it was avoidance of bycatch or choke species. So this suggests that in this particular subset, catch switching was the preferred strategy, but they had, again, all of these constraints on there. So that gave us some insight on the range of responses that might be happening in trawl communities, but you probably are thinking to yourself, well, is that going to be the same for like a long line or a trap fishery that has very different methods of catching? And so our goal here was to actually develop an atlas of adaptive capacity that does geographically scale this entire region and actually looks across these gear types. What I'm showing you right now is the NOAA social indicators looking at different commercial fisheries engagement. And so you can see there's a ton of communities here. And so while my previous work had synthesized quantitative information with interview data, when we're working at this scale, that can be really challenging. So we took more of a quantitative approach to how they had, using vessel trip reports to look at that fishing behavior across this big scale. And so the premise, and we'd love to talk more about this with you, is we're thinking about using past responses to predict the potential for adaptive capacity along those metrics or those axes of change that you could have. All right, so we defined these two classes of metrics in a few ways. So mobility, we looked at variability in the fishing grounds over time. And so I'm sort of showing you a demo of how we did this. We actually used not something like a centroid, but actually the full fishing grounds, like you can imagine like a stack of fishing grounds over time. And we looked at how variable that was through that time series. So something that's more stable would be a low variability in the fishing grounds. A contraction or expansion would be something intermediate. And then something that's actually shifting to new areas would be very high variability in their fishing grounds. It turns out that this actually is correlated with the centroid if you look at it in both axes in many cases. So on the right-hand side, I'm showing you what a low mobility port looks like, where this is the center of their fishing grounds from 2000 to 2015. It's essentially a single dot. They don't move. To high mobility, Beaufort, North Carolina, where basically every single year they're sort of moving slowly north. So keep that in mind of sort of how this metric works. The second was these two catch metrics. So we are trying to think about two ways to capture this. The first is interannual catch variability. And we're thinking about this as how are they able to adapt to a short-term change? Here's a new species. Can I take advantage of it? And the second one was catch switching. So as availability is switching sort of monotonically towards something new, how likely are they to actually shift to that new species? So we have catch flexibility and catch switching are the two things that I'll refer to. I'm not going to show you sort of some of the math behind it, but happy to answer those questions afterwards. All right, so to help you visualize what the difference is between these two, I have a few example communities. These are real data. So we've got a couple different species represented by the different colors and some time series. So this first community has both low flexibility and low switching. So it's really just sticking with the same thing. This one has medium flexibility and medium switching. And it's medium switching because it's pretty gradual change towards that second, so from black to gray. This community actually has medium flexibility, like it actually has some variability, but no switching. It actually had an intermediate period where it tried something new and like, just kidding, let's go back to the other thing. And then the last one is a high flexibility, high switching. This particular one has a lot of interannual variability in the first part of the time series and then really switches to that black species by the end. All right, so if we just look at the catch variability metrics, or catch flexibility metrics, what does that look like overall? And if we, does gear help us explain some of those patterns? All right, so here I've got catch flexibility, our sort of index on the x-axis, and then the different sort of frequencies of this pattern, this sort of strategy across the gear types. I know there's a lot on here. I'll sort of help walk you through it. So first, I find it helpful to look at a very similar gear type between two. We have lobster pot and other pots and traps. You'd think that they were actually pretty similar. They'd use the same kind of gear, but actually we have completely different strategies. So the lobster pot industry or fishing communities have really low catch flexibility, sticking with the lobster, and the other pots and traps actually are much more dynamic. So that really shows you it's not just a function of the gear. It's really about something else about this fleet. If we look at the other, filling in some others, groundfish trawl is sort of a medium catch flexibility, and dredge and shrimp trawl are low. Again, you might think, okay, dredge is really scallop, shrimp trawl really shrimp, so these kind of make sense. Interestingly, we actually didn't find a relationship between this catch flexibility and a measure of diversity. So while it is true that the maximum possible value is a function of the species diversity, the realized effect of that doesn't seem to pan out. So we actually have many communities with low flexibility, even though they have high catch diversity, and vice versa. All right, so how does this actually map out onto gear types? We've got lots of different gear types here, and I just want to sort of, let's focus on one just to make it a little bit easier. If we look at some of these more less selective gear types that you think of in your head, they do have greater overall catch diversity, so they're found on the right-hand side of this. But they actually have wide range of catch flexibility for that same catch diversity. So again, that's not a predictive power. There's something about these communities that's something different than both their gear type and their catch diversity. All right, so this suggests that there is some sort of community level variability in how they're responding to short-term changes in availability. All right, so how are communities switching what they catch? Again, same kind of orientation. Now we've got catch switching on this x-axis. Again, we've got the lobster pots showing some pretty, the pots, two pot things showing pretty different things. Really low catch switching for the lobster pot, but now we actually have a little bit of a tail where we do have some switching. And then other pots and traps is really high. Again, we actually have a similar qualitative pattern or qualitative ranking. So we've got the trawl in the same kind of medium position, and the dredge and the shrimp trawl again being low. So we do have some power to think about this in terms of like the average, but we also, I hope you notice, like dredge has like a big old outlier over there. So there's definitely some variability within that group. All right, so what does that look like? I sort of highlighted that there were at least a few catch switchers in even the lobster fishery. So if we fill in who those were that I showed you before, it's actually Jonesport lobster on the left and Montauk lobster on the right. And so we can see same predominant species, lobster, but one is switching to Jonah crab. And so why might that be? It turns out that southern New England lobster have crashed in the last decade or so, probably due to warming, not just directly on the species, but also via disease, while lobster is going like gangbusters in Maine. And so we actually have these distinct strategies that do depend on their geographic location within the range. Okay, so thinking about these two together, we do have some relationship perhaps between catch switching and catch flexibility, but again, my takeaway here is there's a huge range of how these different communities are responding. There's not a clear trade-off, there's really like this big range of how these different communities are responding. Okay, so are there trade-offs in the two kinds of strategies, catch versus fishing grounds? So in this case, I'm just going to orient you to these slides that the top quadrant is, or the top left is catching the usual, but changing where they fish. The top right is change up where they catch and where they fish. Bottom right, change up what they catch and stay put. And then catch the usual in the same fishing grounds. So when we lay this on with the gear types, we actually see that there is a group that catches the usual, but change where they fish. So dredge, like scallop is moving around. We have a group that changes up what they catch and stay put, so gillnet, the orange one, and lots of our small trawlers. Large trawlers, when we scale up across that whole geography, actually are found in sort of both of these sort of catch quadrants. And interestingly, our previous analysis, our focal trawl communities from the previous study all fell down in this bottom. And so it turns out, careful what you do if you're looking at focal communities. You actually, this broader perspective was helpful. And last, I want to highlight that the lobster and shrimp trawl are down here in this quadrant of low catch flexibility and low fishing ground mobility that worked for them in the past, but might suggest lower adaptive capacity in the future. All right, so how does this actually map on other indices that we might already have for vulnerability? If we look at things like the NOAA Social Vulnerability Index for the highly engaged ports, you might think, oh, well, maybe if they're highly engaged, they might sort of respond similarly, and those that might be lower engaged might be doing something different. We actually don't find that. We actually find that the main driver of where the port as a whole, or on average, falls is very much dependent on the portfolio of fleets they have there. And so that suggests thinking about the portfolio of fleets can be complementary to something that you might do at the census level. And it really doesn't sort of match on to engagement neatly. All right, so to conclude, mobility of fishing grounds was more common when we thought about other gear types, not just our trawl. There's also a big range of catch flexibility that wasn't explained completely by catch diversity, though there are some sort of drivers by gear type. Catch switching was evident both in our more sort of selective or single species types of gear, as well as the ones with greater catch diversity. When we think about them together, we see shrimp and lobster as potentially lower future adaptive capacity. And finally, thinking about the portfolio of fleets in a port can really complement other sort of more full community level metrics of social vulnerability. I know I don't have much time, but thank you so much, and I'll acknowledge my funders, and I'll take any questions if there's a very short amount of time for.
Is the mic on? There we go. We have time for like one really super fast question.
I'm here all week also, so please come approach me.
Okay, we'll move on to the next.
Sounds good.
Sorry. Yep, so I'd like to welcome Marta up, who's going to be speaking about species diversification, economic portfolio, and connectivity within Balearic Island small-scale fisheries. So Marta, I saw you earlier. Are you here? Oh, cool.
Hi, thank you. Okay, thanks all, and thank you for organizing this nice session. I am Marta Albo from the Spanish Institute of Oceanography, where I'm starting working on climate adaptation of small-scale fisheries. This has been already explained this morning very well, that the importance of small-scale fisheries. And in order to know that adaptive capacity, we are focusing on trying to identify the diversification and synchrony of fishing portfolios. So my study area is the Balearic Islands in the Western Mediterranean. The Balearic small-scale fisheries have a high seasonality portfolio. They represent 25% of the fleet, but what we have seen is that in the last 2 decades, there has been a decline of more than 50% of the vessels and also fishers. So that means that there is a loss of traditional and experiential knowledge that combine it with climate change impacts and all the heat waves that are occurring. We expect to see changes in the small-scale fisheries behavior. So our main objective was to study how fisheries are connected through landings portfolios and seasonally targeted species, and also to see if fisheries diversification strategies change through time. To do that, we have daily landing data from 2010 to 2020. From today, I will only explain the data from the main island, Mallorca, that we have 10 fishing communities that we have subdivided in 3 areas: north, southwest, and southeast. And in Mallorca, the portfolio of species is quite diverse. If we look in terms of total landings, the Coryphaena purus, the dolphin fish, is one of the main targeted species, but is highly seasonally, this fishery. But in terms of economic, the spiny lobsters, Coryphaena, Sepia, also becomes very important. And I wanted to highlight to show that there is very specific seasonally fisheries. The transparent goby boat seine, that is a very short period during the year of very tiny gobbit that is really appreciated. So in many of the fisheries, there is a high cultural importance. And actually, I remember since I was a child, my mother cooking only 2 or 3 times a year these very tasty croquettes done with this fish. So there is a lot of tradition with this fishery. And also, if you look at in 2018, the Tunus tinus, the bluefin tuna, started again to increase, and I will talk about that later. So to study how the portfolio and how the tactics have changed, we are applying temporal network analysis, and also to see the portfolio diversity, we use some indexes based on previous work, and that actually Mary Fisher already was before explaining some. So mainly, as you can see here, this is the chronogram of fisheries strategy rotation métiers that has been identified in Mayol and Gogni from 2019. I will not go through all of them, but the fishing tactics are very diverse, using lamprey nets, trammel nets, long lines, hand lines, and many, many more. And as you can see, many fisheries are only taken during 3-4 months. So we had this daily landing data. So first we used cluster and simple analysis to identify which tactic was used every day, because they can only use one tactic per day. And we built the matrix of trips, that each node of the matrix is a fishery tactic, and there is a connection between fisheries tactics if within the same month one boat goes to one fishery and another one. So that makes that we can catch the seasonality within our matrix. And then we applied the metrics of the network analysis, and also we calculate Shannon and Simpson index for diversity of portfolio. So I will not go super in depth in all of the results. These are the networks from 2010 and 2011. What we can see is that in all the areas, the rocky fish is one of the main tactics that have the higher node bigness. That's why this is one of the tactics that is used during the whole year. So we expected to see it quite important that. And also I want to highlight that, for example, this Serranus fishery is a handline fishery that is only practiced by by the older fishers, and it's disappearing. That's why in 2018 and 19 we don't see anymore this node in the north of Serranus. And instead, what we see in 2018 and 19 is that the Dentex fishery, that is a long-line fishery, becomes more shared with other fisheries, because from some interviews that did some colleagues, they have seen that younger fishers prefer long lines instead of trammel nets, because they are less costly to maintain and they need less knowledge to go fishing, because the trammel nets they need and the gill nets they need like to know very well the fishing grounds and the environment. So with the decrease of the number of fishing, we are losing also this knowledge on some fisheries. While what we see here is the measures of portfolio diversity. The first one is the Shannon diversity, to see how diverse was the portfolio, if it changed through time. What we observe is that in the southwest, the portfolio is very stable through years, while in the southeast and north, there is more variability. And in 2018, there was a decrease, but seems that it has been recovered then. But in any case, we see that the portfolio is very diverse, and when we look to the dominancy using the Simpson diversity index, we see that the inverse of the dominance, so goes from 0 to 1, and 1 is like no dominancy of one species, and 0 is high dominance. So we see like values are high, so there is no high dominance. So the fishery is quite diverse, and they don't depend only on one of the resources. And looking at the metric of H density, that is a metric from the network analysis that divides the number of H's between nodes divided by the number of nodes, and can be interpreted as an inverse of the sensitivity of the fishery. We see that the sensitivity that goes from 0 to 1, 2, is normalized, is also not very high, but not very low. So we will say that they are in the middle range of the sensitivity, with the north looking a little bit more sensitive, the fishing network, than the southeast and southwest. And we also see that in 2018 and 19, there is an increase of the H density. So apparently they are becoming less sensitive. Sorry. So to wrap up, what we have seen so far is that there is a high connectivity in the fisheries target. Also, I didn't explain, but we see how in 2018-19 we already have more links between networks, so it became more connected. And this is mainly due to this increasing or using long lines during more months during the year. So, and also we see with the diversity indexes that Mallorca presents a high potential for adaptive capacity because they have a quite diverse portfolio. But of course, here we are not including socioeconomic and other ecological threats that needs to be included. And this is what we are going to do in the next steps, because this is a project that we just started at the end of the last year. And now what we want to do is with this network also include weights in the nodes with economic information, and also conduct interviews to get this local ecological knowledge and to interpret better the data. And also we are starting to analyze the environmental variables and climate velocity with the landings to understand how much is explained by the environment and by the heat waves and climate velocity. And if you are interested in that environmental part, you can go tomorrow at the same time to session 3 that Marina Sanz will explain more about the climate velocity related to the landings in the Mediterranean. So as we are just starting this project, the CLISARTES project, I will be happy if you can give us any input or if you have any comments or recommendation. And tusen tack for listening.
Has anyone got any questions?
Hello, thank you for a great talk. It's really interesting. I'm curious, near the beginning of your talk, you mentioned how you've seen a 50% drop in participation in the fishery or number of fishers or something like that. And I'm curious what effect you think that's had in your model. It's interesting to see that, you know, things like diversity haven't gone down. You're not losing particular strategies. And then is your understanding that the fishers that are remaining are still sort of fishing all of these different fisheries, even though there's fewer of them in aggregate?
Yeah, of course, technology has helped to maintain the effort, let's say. But what we are here is only from 2010 that already many fishers were gone. So we don't have the baseline here, no? And that's why now we are trying to get at least the data from 2000s, but it was not possible to have it yet because sometimes it takes time to obtain the data. And I guess if we have a longer time series, we will be more able to see the differences. But it's true that some very small fisheries like the Serranus one by handline, you can see how disappear already. But other ones, I think before 2010, they already disappeared. So we are losing that information here. And hopefully we will have a better picture in few months. Yeah, thanks.
Thanks, Marta. I'd like to introduce Jameal now to talk about the influence of mobility and flexibility in the groundfish bottom trawl fishery on the US West Coast.
Thank you. Good afternoon, everyone. I'm here from NOAA's Northwest Fisheries Science Center in Seattle, Washington. And I hope I don't win the award for the talk title with the greatest number of syllables, but it sure feels like I might. I'm going to try to make the case today that in order to prepare best for climate change, we need to understand the risks due to climate change in the places that people are actually using the ocean, and to think about how adaptation potential works in those places. So in the US and actually around the world, roughly 4 out of 5 fisheries are considered to be managed in a sustainable way, and they generate billions of dollars and millions of jobs annually. So really critical to the US economy as well as the global economy. However, climate change, ocean warming, ocean acidification, and everything else we'll hear about all this week are threatening our understanding of whether those fisheries will continue to be sustainable. Not only that, but other types of ocean change, such as emerging ocean uses like offshore energy development, really offer some potential for there to be shifts in the way that fish and fisheries operate, which could also cause our notion of sustainability to be a moving target. And so a common need from all of these types of ocean change is to increase our understanding of community-specific social and ecological consequences of those changes. On the US West Coast, if you were here for Mary Fisher's talk, we've engaged in something called the Climate and Communities Initiative Scenario Planning Exercise. I know there are plenty of other scenario planning activities occurring across the world. And this is one way to try to get a handle on the plausible futures facing fisheries. However, there are other ways, and I'm going to focus on that a bit today, and in particular, thinking about adaptation options. And oftentimes, when we talk about adaptation options, our focus is on a key question, as you heard in Becca Selden's talk just about a half hour ago. And that's, can we stay or should we go? In other words, can we continue fishing in the same places, or is it going to be important to move to fish somewhere else? Lauren Rogers led a paper a few years ago looking at this off the northeast coast of the United States, actually estimating environmental change within fishing grounds in the northeast US. And Becca has shared with us some examples of how we can think about flexibility, both in terms of species that are targeted for fisheries catch and in terms of mobility, or where fishing actually occurs. And so what I'd like to do now is take more of a forward-looking guess at what vulnerability to climate change may look like for fishing fleets on the US West Coast. I'm going to present this assessment of climate change vulnerability in two ways. One, based on an adapt-in-place assessment, and second, based on an adapt-on-the-move assessment. And I'll tell you what I mean by that. In both cases, I'm going to develop an integrated measure of social ecological vulnerability based on three indices: exposure, sensitivity, and adaptive capacity. For the adapt-in-place assessment, the estimate of exposure that's the ecological vulnerability side of the equation here, and that's going to be based on using dynamically downscaled Earth system models that have been developed by Mare Pozo-Buil and Mike Jaycox and colleagues to estimate the amount of environmental change that will occur within today's fishing grounds. For the social vulnerability side of the equation, I'm going to estimate sensitivity based on the economic dependence of fishing fleets on target species. And finally, for adaptive capacity, I'm going to narrow in on one dimension of several for adaptive capacity and focus on flexibility or catch diversity that's possible, or portfolio of fisheries. In the adapt on the move assessment, I'm again going to use this structure of exposure, sensitivity, and adaptive capacity to generate a vulnerability index. The sensitivity component will be the same. It's still going to be the economic dependence of the fleets on these target species. But in this case, the exposure index is going to be based on the idea that the fishing fleets may move to sort of chase the fish or the environment that they're used to fishing in. And so this is going to be based on an estimate of projected environmental change, or how much deeper fishing fleets may need to fish in order to find the same temperature profiles they fish in today. For adaptive capacity, rather than focusing on this sort of notion of diversifying catch within place, I'm going to be focusing on this notion of adapt on the move. So how mobile are the fleets today, and therefore how capable are they of moving to chase the fish? For those of you that aren't familiar, let me just briefly introduce the US West Coast bottom trawl groundfish fishery. It consists of over 100 managed and beautiful species, ranging from black cod to Dover sole to many species of rockfish. This fishery is a bread and butter fishery on the US West Coast, operating year-round, keeping processors open. But it's also a fishery that's been in decline for a long time. And so it's now highly embedded within a fisheries participation network, much like the ones that Marta showed in the previous talk. And so the groundfish fishery is kind of an essential linchpin within West Coast commercial fisheries in the United States. Whereas 40 years ago it generated $100 million a year annually, these days it's more like 20% of that. And not only has the economic revenue generated by the fishery declined, but it's also consolidated so that, as you can see in the yellow bars, most of the revenue is generated in the state of Oregon, then in the blue bar in California, and finally a bit in Washington state. And so what this does is it sort of sets up the idea that there's some pre-existing conditions suggesting that the groundfish fishery may be vulnerable to additional impacts, such as those that climate change may bring. So let me step through the vulnerability assessment in these two ways, adapt in place and adapt on the move. As I mentioned earlier, the index of sensitivity is going to be the same for both of these assessments, and based on the share of earnings that come from the groundfish bottom trawl fishery relative to all other commercial fisheries for the West Coast fleets. And so, as you can see in this figure, moving from north to south, we've got about 14 different fleets. Where they operate in fishing grounds is shown in the gray polygons along the map here. And generally what we see is a decline in the economic dependence or sensitivity as you move from north to south. This relationship between latitude and sensitivity is actually statistically significant, so that northern latitude fleets are more sensitive or more economically dependent on bottom trawl caught groundfish. So next I'm going to move to talking about the estimates of exposure, the second component of vulnerability under an adapt in place and an adapt on the move assessment. And again, there's two different measures of exposure here. The first is based on the expected environmental change, and in particular change in bottom temperature within today's fishing grounds relative to historical variability. So that's what's happening here under adapt in place. And then the second is based on imagining that the fleets will move to find the thermal profiles that they're accustomed to fishing in today towards the end of the century. And in order to find those cooler temperatures, they'll have to move deeper. Under both of these estimates of exposure for adapt in place and adapt on the move, what we find here is that higher latitude fleets are more exposed to climate change. So on the left here, what we're seeing as we move again from north to south is that there's greater thermal change expected within these fishing footprints for more northern fleets than for more southern fleets. And there's also greater vertical displacement of bottom isotherms for the more northern fleets compared to the more southern fleets. So far what we have then is that more northern fleets are both more sensitive and more exposed, whether we imagine that they adapt in place or on the move. What I'd like to do now is talk a little bit about the estimates of adaptive capacity we've made. Again, under adapt in place, we're imagining that the fleets are going to diversify their catch, and we estimate this fisheries portfolio diversification using networks much like Marta showed to get at the potential. For the fleet mobility, we use a landings-weighted estimate of distance from port, so how far fishing grounds are from where the fish are landed. So the measure of diversification relative to latitude is on the left, the measure of mobility relative to latitudes on the right. And what we see is that in the adapt-in-place strategy, there is a weak relationship between latitude and diversification, such that more northern fleets are less diversified, but there's a lot of variability there, and so that doesn't seem, geography isn't a great explanatory variable for this potential adaptive capacity. In contrast, if we think about an adapt on the move strategy, what we see is that more northern fleets are more mobile, suggesting they have higher adaptive capacity in the face of climate change that may ameliorate their higher sensitivity and higher exposure that we saw in previous slides. So if we put that together, what do we see when we generate an integrated social ecological vulnerability index? We see that, in fact, the adaptive capacity under an adapt on the move assessment is not enough to mitigate the higher sensitivity and exposure, and both in an adapt in place and an adapt on the move assessment, we see higher social ecological vulnerability for more northern fleets. So what does this tell us? Well, I hope what I've done is introduced a tractable and scalable approach for quantitatively estimating vulnerability, at least for large-scale fisheries, not only on the U.S. West Coast, but beyond, and demonstrated an approach for evaluating environmental change where it matters most, as well as adaptive capacity that's grounded in the places that people are fishing and the behaviors that they've exhibited over recent history. But what I haven't done is show you how to solve the problem of this vulnerability. And if you were here earlier for Kathy Mills' plenary talk, you'll see that she and colleagues have developed this climate resilient fisheries planning tool, which offers governance, ecological, and socioeconomic attributes that can be leveraged to increase resilience of fishing fleets and fisheries. And in particular, a talk that followed Kathy's by Tanaka showed how, for example, learning and knowledge through autonomous adaptation or adaptive governance measures could be used to, for example, introduce ways to enhance mobility, fisheries diversification, or other measures to help better mitigate the risks of climate change. Before I close, I just want to offer that this is a work that I've presented is based on a broad collaboration of co-authors and colleagues. We call it the GC5 project, Groundfish, Climate Change in Communities in the California Current. Please check out Owen Liu's talk, which will show you a little bit of what we've done for projecting species distributions. That's tomorrow. Isaac Kaplan's talk on Atlantis ecosystem model simulations happening Thursday. And then in just a half hour, Chris Harvey will be talking more about how we've approached the potential impacts of climate change on communities. And Karma Norman has a poster on this same topic as well. Thanks very much for your attention.
Thanks for that great talk. We have time for one question.
Thank you. I'm curious about the sort of few ports in Washington that just seem to have super low vulnerability. And I was wondering if you could talk about how much that's because of climate change in Washington versus just like historical changes in the fishery in that part of the world, making them super low resilience to anything as communities.
Yeah. So as you no doubt saw, the only element of climate change embedded in this assessment is that estimate of exposure. And so that is really where it comes in, so based on the expected environmental change in the fishing grounds. So that's real. The other two components of vulnerability are a legacy of changes that have happened in the fisheries and in those Washington fleets over time. And I think it'd be best to talk on a boat later today about that, because it's a really complicated story that's sort of developed over decades that's led to that social vulnerability.
Thank you. So next up we have a remote talk from Eneko Bachiller over in Spain, I believe, talking about adaptive small-scale fishing effort in the eastern Cantabrian coast.
Hey, good afternoon, everyone, and thanks for attending. I'll thank also to the conveners for giving me the floor to present our latest research about the small-scale fishery in our region, which is this one, this southeastern part of the Bay of Biscay. This is the Basque Country, and you can see here there are several different harbors, but we should say the small-scale fishery is concentrated in 4 of them, which is Pasaia, Getaria, Lecatio, and Bermeo. So those 4 harbors are concentrating most of the landings that are coming from small-scale fishing. So before going to the results, also to make it clear that the small-scale fishery in this study will correspond to those vessels less than 18-meter length, which are based in our harbors and that were active from 2010 to 2021. So that means active vessels during the last decade. And that gives us a data set based on 57 different commercial fishing vessels. and a data frame of more than 50,000 fishing trips. So those trips will be separated based on the fishing gears, which mainly are those 5 groups. Handlines, which are hooks targeting small pelagic fish. In our case, that means hooks targeting mackerel, Atlantic mackerel, Scomberus scombrus, which takes place during spring. Then the demersal long lines, which are hooks targeting demersal fish in our case. Gill nets and trammel nets will be considered together as passive gears or netters. Then pots and traps as another group. And finally, trolling lines targeting northern albacore, Tunus alalunga, which takes place during summertime in our region. So this is our data frame. And then we'll see what's going on with the fishing effort and in terms of fishing days, total number of fishing days, and the number of vessels or the number of active vessels from 2010 to 2021. So in general, we saw there is a declining trend in both fishing days and number of vessels. But if we go more into detail, we see that that declining trend is mostly due to changes on the effort by netters and longliners. So in this case, those 2 lines in the top part of the plots, that belongs to gill net and trammel nets, both significant declining trends in terms of fishing days in the left-hand side and number of vessels in the right. And the same could be said for longliners. So it's a less number of fishing days and less fishing vessels operating in recent years. In contrast, for handlines targeting mackerel in this case, there is a higher activity in the recent years for handlines, even there is no significant difference in number of vessels operating with that gear. But for trolling lines, it's quite clear that there is an increasing trend in both fishing days and number of vessels operating with that trolling lines. Finally, for pots and traps, there was no significant difference, neither for fishing days nor for the number of fishing vessels. So if we separate the fishing trips based on the landed species distribution, we saw that this grouping corresponds quite well with the fleet segmentation that we previously defined. So we know that the pots and traps are targeting quite different species from the other segments, mainly octopuses and crabs. And here, handlines targeting mackerel appear also quite well separated from the others. And the same could be said for northern albacore, targeted by trolling lines. So we will focus on those showing declining trends, which were netters and longliners, which are at the same time showing higher overlap in the species, landed species distribution. So what's going on with those two? Well, for netters, remember, it's less number of trips and less number of vessels operating in recent years. They are landing around 15% of the total landings by the small-scale fleet, and there is a decreasing trend of the total landings as well for the netters. Is there any change on the targeted species, or is there any explanation on that? Well, we use this Costello-graphical method to see which are the main targeted species. That shows the percentage of occurrence of that species on all landings in the x-axis, on the horizontal axis, and the percentage of frequency in the vertical axis. So that means farther right and farther up of this panel, the certain species located, that means it would be more important species for that corresponding fishery. So we filtered and we just kept those species that are higher than 10%, just to clean a little bit the plot. And we see that the most important species are the hake in almost all the years, and also some monkfish and anglerfish, depending on the year. So it doesn't seem there is a quite big change on the targeted species during the last decade. In any case, if we have a look to the landings of the main species, which are hake and monkfish and anglerfish were just considered together for this plot, we see a declining trend in both species. If we have a look to the market, just in case and if there is any potential explanation of any certain changes, we see there is an increase on the price for monkfish and a decrease on the price of hake, but not quite big changes that might suppose an explanation for any kind of trends for this fishery, not at least for this stage. So if we make the same analysis for longliners, there was no change on the landings of this fishing year for the last decade. It's more or less the same percentage as the netters. It's 15–17% of the total landings by the small-scale fleet. And the main target species by longliners are different from netters. Congers are one of the most important, and also sea bream and sea bass appear as the main targeted species. Well, if we go to and see the landings or the trends in landings, there was no significant difference. Well, a little bit less amount of sea bream landed in comparison with the early previous decade, but not much. And in case of the prices, there was no difference in any of the species. So at least in these cases, it's not the market demand or a change on the targeted species that could be observed. So as a take-home message, we see that boats and traps are quite lower in activity in comparison with other fleet segments, but they are remaining more or less the same during the last decade. While there is a declining trend in both netters and longliners targeting different species, but with no clear changes on the prices or on the target species throughout the years. And on the other hand, we see a clear increasing trend on the handlines activities targeting mackerel in the spring, and also the same, an increasing trend on the trolling lines activity targeting northern albacore during summer. So we see the prices of mackerel and northern albacore. It's a little, well, there is an significant increasing on the prices of the mackerel, but not much, and the price of the northern albacore remain the same. So should be something else, but not the price, which would make some special interest for this increasing activity. In any case, if we have a look to the netters and the longliners, those guys which were showing declining trends, and we make the analysis of which percentage of those are then also using handlines during the spring, then we see that it's quite a big increase on the percentage of the netters that are using the handlines and also the trolling lines. So this upper liner, straight line here, corresponds to the percentage of netters that are then incorporating handlines in the spring, and this dotted line corresponds to the percentage of netters that are turning into trolling lines in summer. And the same could be said for longliners. So these are longliners that are then turning into handlines in the spring, and the trolling lines incorporated. So almost no one was using trolling lines in early 2010 if we consider netters and longliners. But nowadays, most of the longliners and most of the netters are using both hand lines in spring and trolling lines in summer. So that could be kind of an adaptative trend just to complete the whole fishing year with other targeting species and using other fishing gears that might be more interesting in terms of cost effectiveness and other stuff that we should then consider more into detail and make some more research just to conclude on some clear trends. But at least some changes are appearing here, and we now expect to extend this analysis to a wider time period. And that's pretty much most of the things I would like to present in this talk. So if you have any question, please write me an email, or of course, now if there is some time, you can make some questions and I'll do my best to answer. So thanks for your attention, and have a pleasant stay there in Bergen. Bye-bye. Thank you.
Hello. There we go. Thanks, Eneko. If anyone has any questions, I don't believe that we can do live Q&A. Please get in contact with him through the app. So I'd like to welcome now Heike Schwermer, who will be talking about mapping and assessing governance system of German small-scale fisheries.
Thank you. So yeah, thank you for having me here at the session, and there were really great talks this morning and also this afternoon presenting very diverse case studies along the globe. And today I would like to present you some insights from another case study which is in Germany. So, and we focus in our case study more on the governance system. And we mapped the governance system and did some first assessment of what the performance of the system is. And just to give you a brief context what the small-scale fisheries looks like and where it is based on, we have the map of the North Sea and the Baltic Sea, and the fisheries is mainly operating in coastal areas, which is quite a characteristicum, I think, along the globe. But what is a bit different might be the fishing gear which has been used. We saw some case studies where it's more like really trawl fishing used or traps or something like that. But in the Baltic Sea, for example, we have gill nets and pots which are quite popular in use and in frequency. You can spot them easily if you go to the harbor when you see this red flecks in the harbor, which is quite nice and a nice atmosphere for those who like that. And but we have also like active fishing gear, which we encountered just trawls which have been used, but this is mainly in the North Sea area. And just to give you a bit of pictures what the small-scale fisheries looks like in Germany, we have some pictures from the Baltic Sea. And we have also one picture from the North Sea where we have a bit bigger boats because they have other conditions to fish where. And both in the North Sea and the Baltic Sea, we have different challenges the small-scale fisheries is facing at the moment. You heard that quite a lot this morning and also this afternoon. There are like overfishing happening quite a lot, and we have eutrophication, which is quite a huge impact in the Baltic Sea area, but also in the North Sea. And then we have climate change, which is the topic of the whole symposium. And just to make an example to highlight a bit what challenges the small-scale fisheries is facing at the moment. So due to climate change effects, we had a really high decrease in the spawning stock biomass of cod, which was a target species for the small-scale fisheries, but it's not at the moment. And this is the reason why, is that the quota got decreased quite a lot. And by 2023, so the year at the moment, we have only a bycatch quota which was negotiated at the European Union. And we have kind of the same story with another species, what was supposed to be like a target species for the small-scale fisheries in the Baltic, which is the herring. And we have different stories also in the North Sea, where we have the shrimp fisheries, which are also facing quite a lot of challenges at the moment. And due to that challenges, we have a really sharp decrease in the number of fishers, and the fishers who do it as a main business, but also at the side business. And due to this decrease, there's also Fisheries cooperative, which closed down, and also the lobby of the fishers is really like decreasing a lot, which is like not a good situation to fight for the rights for the small-scale fisheries at the European Union, for example. And you might think, okay, this, the situation is quite bad at the moment, what we can do. So we have, on the one hand side, a quite vulnerable system due to ecological conditions, but also to socio and economic conditions. And then we have an European Union and a policy into place which has very good measures. But the question is whether these measures are really the good measures to face climate change and adaptation of the small-scale fisheries due to these changes. And this is the reason why we looked into this governance system more closely. And to understand the system a bit better, we first need to map the system. So which different actors and linkages exist between these actors. And also due to that, we wanted to assess the performance of the governance system. But this is more an ongoing work at the moment. And so we wanted to find out, so where are the strengths, but also where are the weaknesses where we can maybe work on more closely. And then there's also the question of this power holders. So who are the institutions who have the most power, but who are the institutions who should have more power due to climate change adaptation? And as we know, and we heard quite a lot yesterday, but also today, that we have different perspectives on the system, so and also different knowledge types surrounding the systems, and we have different stakeholders interacting in different subsystems, which then being a huge system. And that is why we applied a transdisciplinary approach to get the most data we can get and the best understanding of the system. And we did, for the mapping, we started, so this is like a 7-step approach. We started with data sampling. So this consists of interviews. We conducted 8 interviews, which might sound not that many, but the intention was not to repeat the data and the information we have, but we really looked for stakeholders who act at different governance levels, who act in different fields and have different expertise. So stakeholders from fisheries, but also from NGO and management, and also from science. And to compile our data and supplement our data, we did a really comprehensive literature review. So we read through very different legal frameworks and regulations, but also to different websites of actors who were like presented as relevant by the interviews. And then we had lots of informal conversations with stakeholders in the field just to complete our whole data set. And after that, we processed our data via text coding, so looking where are the different actors and what are the different linkages between them. And after we visualized all this data in so-called governance maps, which I will show you on the next slide, and then we did quite a lot of work on putting all this data in an Excel file, so where you have all these actors, the different levels, the different interaction described really in detail, and also with references for those who are really interested in the field. And we put lots of effort in this because we also will share all these maps that stakeholders can use for communicating and for discussing possible adaptation strategies, and also for people who come, who are new in the field. They don't have to do all this work for months and so on, so they can use this data, what we already processed. Yes, and this is just very quick overview how the maps might or look like. So in total we had like 6 different subsystems. The reason why is that we didn't want it to make it too complicated and put all actors, all different linkages in one map, because then no one can really use it for communication or whatever. So we divided the whole fisheries governance system in 6 maps, which are like legislation, resource allocation and control monitoring, and then 3 others. And on the right side, you can see a picture of the resource allocation governance map, and there are different colors you can spot. And there's like the reddish color, these are the governmental institutions, whereas you have bluish color, which are like the non-governmental institution. So we stick to this very broad differentiation just to make it too complicated. And then we have different interaction types. These came out by the whole data sampling and discussion with the stakeholders we had. Some might think maybe it's too complicated, but in terms of discussing different strategies and adaptation possibilities, in some cases it might make sense to be a bit more specific. And so we have a very broad one, which is like informal interaction and informal action, so that can be, a lot of linkages, but then we became very specific. So we have information and data, licensing and regulation. And what you can see, and maybe I should have asked this in the beginning, the fisheries in the Baltic as well in the North Sea, it's not only the small-scale fisheries, so we have also the high seas and the small high seas fleet, but this is not the context of our discussion here. And so, but for the small scale fisheries, we can identify different types, so that you can identify them by part-time fishers or by the fishers who do it in a main business. But you can also divide them by fishers being organized in such a fisheries organization, or they are not organized. And the reason why we choose this kind of types of fishers is that it makes a difference specific here to the resource allocation if you're organized in a fisheries organization or not. 2 minutes left, and I knew that. So I skipped these 2 slides, and maybe just very quickly regarding the assessment of the fisheries governance system. So also there we use different approaches and different methods. And we also use the interviews we conducted for the mapping. But also we use quite a lot of social media, for example, and also newspaper. And this is an example from an Instagram channel from a fisher. So the good thing is in the Baltic Sea, for example, that there are really a lot of fishers who use Instagram, which is quite nice, because then you get a really nice insight into the system and get really nice context. So, and this was just last week where a fisher posted a picture. Some might know that there is a cod inside. So coming back to the example from the beginning and the really decreasing cod stock at the moment. And he is really explaining that in his net he had really like small cod. But due to the governance system and to the regulation, which is called here the landing obligation, he has to take them on board and land them. But I mean, the incentive of this landing obligation is due to this discard ban that fisheries should fish more selectively. But they increase their mesh sizes and they arrange the gear a bit different. But the only fishing gear which is encountered here as selective are pots and traps, but really less fishers use it because of economic reasons. And the thing is here that he is kind of really sad of not leaving the fish out back to the water, because a cod is a fish who can, if he's not dead in the net and is in a good shape and vital, he can really survive the system. And where we have at the moment the case that there's not much cod around, and small cod would be really like a good thing to leave to rebuild the stocks. That's a really, a discussion which is like, you can say maybe it's a local view on the system, but I have quite good contact to fishers in the Baltic, and there are many who report on small cod in their net and they have to land them. And just really quickly to conclude, I hope I could show you a bit that we have a top-down fisheries system in the European Union. This can be good, but there are also reasons to criticize this system. And at the moment where we have a really system which is like hit by climate change, but also other impacts, maybe it could be a good idea to adapt the system a bit and taking the local perspectives more in this regulations. But then we have different governance levels. We have so many actors acting, and so the ways the knowledge is going from the local to the European Union, it's very long, and the actions are not taking too fast than it should be at the moment, in my understanding. And then we have also in the Baltic, also in the North Sea, a system which is like a multi-use system. So we have tourism, we have shipping, and then we have also pollution and tourism going on. And all these different users have their own policies, they have their own actors, their own mechanism and processes. So when all these overlap, the complexity is increasing quite a lot. This might be also quite challenging, but you can also think of maybe it's also a possibility to think of adaptation possibilities for the small-scale fishery, especially in terms of tourism and fisheries. And then I would like to thank you for listening, and maybe there's still time for a question. Thank you.
So do we have any questions?
All right, thank you very much for this nice presentation and also explaining the maps and the model. So my question is that there are some theories on multi-level governance now, which also talk about this system approach and instance-based approach. So I'm not sure whether you're familiar with this or not, but the idea is that while in systems-based approach, it is about this traditional, conventional model and method of the interactions between governance, the actors at different governance levels. But in the instance-based approach, it is also about the different moments of interactions that also kind of upset and reconfigure, the interactions between the different governance actors. So. So do you have any empirical...
I'm not that familiar. I think of the approach you mentioned, the multi-governance. Yes, definitely. But maybe we can chat after. Yeah, that would be really nice.
Thank you. Thanks.
Cool. Thanks for the question.
Thank you. Okay, so I'll invite the next speaker.
Yeah, it's fine.
So last by no means least, we have Chris Harvey, who will be presenting on climate-ready indicators in US fisheries management and conservation.
Well, thanks a lot. It's an honor to get to be part of such a great session. Thanks, session organizers and speakers, and I'm really glad to get to be a part of this. And I also want to thank my many co-authors and funders for the work that I'm about to present. So we've heard a lot about the different kinds of buckets, if you will, of climate impacts that we're seeing on fisheries and marine ecosystems all over the world. And tracking and addressing the effects of some of these buckets, like shifts in stock distribution, loss of infrastructure due to flooding, and so on, is going to require effective indicators and knowledge sharing, as you've heard from a lot of other presenters. And so the project that I'm going to talk about is one where we are trying to take hierarchical indicator frameworks and qualitative information and combine them together so that hopefully we can shed further light on how to address these kinds of impacts and hopefully inform management in a way that they can make timely decisions. The approach I'm going to talk about is mainly geared toward the US context, but I hope that it's useful for some of you from other parts of the world, as I know the case studies I've heard about today from all over the world are going to be useful for me. So just to dive into US fisheries management a little bit, the framework for, the legal framework for management of federal fisheries in the United States comes from the Magnuson-Stevens Fishery Conservation and Management Act. Magnuson-Stevens is administered by NOAA Fisheries in partnership with fishery management councils from different regions. And this partnership develops fishery management plans that are responsible for management of several hundred stocks around the country's waters. One of the features of the Magnuson-Stevens Act is these 10 national standards, and the national standards are these guidelines that define expectations that management actions are expected to follow. So those might have to do with management actions that should be mindful of sustainable stocks or of fair allocation of catch or of vessel safety, things like that. The national standard I'm going to talk about in this talk is National Standard 8, which we think of as the community's national standard. It says that management actions should provide for sustained participation of fishing communities and should also minimize adverse economic impacts in fishing communities to the extent possible. it should be based on good economic and social data. And in this context, a fishing community is explicitly referred to in Magnuson-Stevens as place-based. Now, I do want to mention before going on that National Standard 8 is maybe one of the national standards that gets a little less attention than some of those other ones, probably in large part because most of our data and most of our analytical focus is on national standards having to do more with stock sustainability. But if we are really going to embrace fisheries as social ecological systems and embrace fishery participants as co-developers and partners in ecosystem-based management, then we need to embrace National Standard 8 just as much. And we also know that the kinds of climate insults that are happening in our fisheries are going to continue to happen at increasing frequencies. And so that's going to mean more and more management responses that require a National Standard 8 informed response, which means we really do need to up our game as far as National Standard 8 related indicators and knowledge goes. And so that's what this project is hoping to do, is to achieve this goal of helping to ensure access to viable fisheries resources and fishing community resilience, which is kind of what National Standard 8 is all about. And so we're looking to the literature and to case studies to develop these general categories of quantitative indicators like environmental, biological, fisheries, and other, and fortify those with information that comes more from the qualitative experience of participants in such a way that hopefully, again, informs good management decisions. A really lovely example of this that Mary Fisher actually talked about a little bit in her presentation just comes from a really nicely built body of literature from the United States West Coast and looks at the effects of harmful algal blooms on the Dungeness crab fishery. There have been several indicators developed that link extremes in temperature to the intensity and duration and toxicity of harmful algal blooms on the West Coast, and have also tracked the occurrence of toxins in the tissues of shellfish. Related fisheries and other indicators have tracked the changes in crab revenues and in related parts of port economies, as well as changes in the duration of fishing seasons and participation in alternative fisheries. And importantly, investigators also went into the communities with participant interviews and surveys to get at some of these more qualitative aspects of how these harmful algal blooms and closures affected them economically, socially, and emotionally, what some of their adaptive and coping strategies were, and how they would deal with a future harmful algal bloom. So what our goal would be able to develop portfolios of knowledge and indicators like this for other buckets of climate impacts. And I'm going to focus the remainder of the talk on an unfolding story that's climate related and focuses on changes in bycatch dynamics on the west coast of the United States. And the focal species here is sablefish, which is a ground fish that supports highly valuable fixed gear and trawl fisheries on the west coast. And there's evidence that's come out over the past several years that recruitment of and strong year classes of sablefish are often linked to oceanographic processes related to transport and related to conditions for females at the time of reproduction. And if we know something about this, that's great because it's potentially a good leading indicator of harvest conditions for sablefish a few years from now. Good news. But juvenile sablefish also occur throughout the water column and are subject to bycatch in other fisheries, other valuable fisheries, like the Pacific whiting fishery and Pacific salmon fisheries. And these fisheries are therefore forced to have some quota of sablefish. It's a limited amount of quota, and it can potentially be a constraint if that bycatch is too high. And lo and behold, last year, these fisheries experienced unexpectedly high bycatch of juvenile sablefish. As this report from the Joint U.S.-Canada Commission that manages Pacific whiting describes, there were large concentrations of small sablefish in all parts of the whiting fishery that actually forced vessels to avoid productive fishing grounds just to avoid that bycatch. Salmon fishers also talked about catching high rates of juvenile sablefish near the thermocline and saying that they'd never seen them there before. So we, as part of the work that I'm involved in, didn't know actually that that was all going on last year. At the time that we are also building up our annual ecosystem status report of the West Coast of the United States for presentation to managers. And one of the analyses that we are working on was actually just tracking the abundance of several juvenile groundfish in the most recent years. And one of them, in fact, was sablefish. And based on survey data as well as some spatial distribution models, we found that the abundance of juvenile sablefish was really going up in 2021 and then especially in 2022. And at least in 2021, this also corresponded with an oceanographic indicator that tends to be consistent with past recruitment events. We also found that this recruitment was quite patchy in space, as you can see in this profile of the species distribution model from 2021, and especially those hotspots indicated in red in 2022. So we took this information with us just last month to our Fishery Management Council and presented to them as part of our overall ecosystem status report. And that set in motion this really interesting chain of events that we just really didn't see coming. So someone who heard our report who did know that that bycatch was going on runs down the hall to tell somebody else, and before we know it, the council is recommending a rapid update of the sablefish assessment several years ahead of schedule in order to try to get out in front of this before what would have potentially been plenty of sablefish biomass was mistaken for the predetermined quota levels that could have determined those bycatch thresholds. So that led to, well, that's potentially going to lead to this positive outcome where National Standard 8 is concerned, where the sablefish quota could be adjusted upward to keep these fisheries open, keep their costs down and so forth, hopefully also balance with conserving some of those new sablefish for future catch. So this represents, could represent anyway, if this is what actually transpires over the next couple of months, a fairly rapid, nuanced, and flexible response by management based on this, this quantitative information. And it's the kind of thing that if we assume that recruitment variability is going to increase for some stocks in years to come based on environmental drivers, this is the kind of thing that we could see happening again. And I just want to once again acknowledge the importance of the qualitative validation that came from fishermen telling us that these trends and potential uncertainties that we were seeing in our indicators were in fact what they were seeing. And this could represent, since it was a positive outcome for them, this could represent a really nice new information source and partnership for us. I don't want to leave it there because National Standard 8 is, as I talked about at the start, a communities-based standard, and that was a fairly coast-wide application. So we're also looking at the potential impacts of this bycatch event in specific communities that rely on whiting. We're going to use network metrics that you've heard about a little bit from previous talks, where this is just a cartoon of what a fishery participation network for a port might look like. Each one of these bubbles represents a different fishery. The lines between them represent vessels that are participating in both fisheries, and we would expect that a more well-connected fishery like this one is potentially more resilient to some shock in the system than a less well-connected fishery like this one. We're also going to look at the NOAA Social Vulnerability Index that describes the social safety net of a different port based on different kinds of social metrics that you've heard about before. And finally, we're also going to look at just the potential exposure to bycatch risk, which is going to be based on the density of sablefish that occurred within the typical radius that the whiting fleet would sail out of a given port. And so our first look here, you can see that actually it turns out that based on the same sensitivity metric of dependence on whiting revenue that Jameal talked about, there's really only 3 ports along the West Coast that are landing an awful lot of whiting. Astoria being the one with the highest reliance on whiting, and these other 2 more middling. The other 16 ports are all just piled down here at the bottom. And this is that connectivity metric from the Fishery Participation Network. It turns out that that Newport has the weakest connectivity of its whiting fleet with other fleets. It also turns out that Newport has the highest social vulnerability of these plots. So if there is a port that we're going to be concerned about in terms of its potential to deal with a bycatch impact on its whiting fishery, Newport seems to be the one right now. We also looked at the same thing once again with respect to the availability of sablefish within that radius. Newport once again came out on top. So if we're going to now go into a community to derive more qualitative information from fishers about how they plan to respond to this or how they did, what their ability to take alternative measures would be, Newport again seems to be a place we'd really want to focus our attention. So with any indicator-based approach like the one I'm talking about, there are, of course, challenges galore. So if you're a glass half empty person, you're familiar with the challenges associated with data availability around indicators and monitoring programs, challenges with scaling, and there's the inevitable issue of correlation versus causation. It's also possible that a place-based definition of community shouldn't be the only one that we're thinking about when it comes to National Standard 8, because there are communities of practice and communities at sea that are also critical to our fisheries. It's also critical that we figure out a way to get this timely delivery of relevant results to managers, not me saying something and that guy running down the hall and we luck out and something happens. There needs to be something that's more structured and put in place so that the timing is right. And finally, there's very unlikely going to be a simple recipe for which indicators to include for one of these kinds of impacts. It's going to have to be tailored. But on the other hand, if you're a glass half full kind of person, the great thing about this is it really does emphasize key social outcomes, not just yield. It involves co-development of information with participants. I don't remember why I italicized this, but it's a good thing that there's meaningful application of their knowledge. That marriage of qualitative and quantitative information may help disentangle some of the cumulative factors and actually identify mechanisms for why fisher behavior changes. And then finally, a lot of these indicators could go on to support predictive models for how climate risk management and adaptive planning could go forward. And there have already been some really nice studies that talk about that kind of predictive modeling for some of these buckets of impact. I really appreciate your time, and I think I've used my time up, so it's beer time, right? Thank you so very much.
We can take one very quick question if anyone has one.
Rudy.
Thanks, Chris. Very nice. So, I'm very impressed that actually the uptake for the quota change of sablefish would be that fast. So I'm just wondering, so if I got it right, this would be a change towards a higher bycatch quota. Do you have any feeling if such a fast reaction would go as smoothly if it would be a quota reduction? So
That's a terrific question, and thank you. And I don't know of precedent for this rapid, at least a potential reaction in our system. And it is actually like one of the things that our managers and our fishers have been asking for the most is ways to increase flexibility. And this is the closest thing I've seen to it happen on the ground. And it's also a little uncharted as to how it's going to go because, yes, it could involve increasing the bycatch quota, but that's based on spawning stock biomass. And what we're talking about here is bycatch of things that are this big, which speaks to how important it is for when we do surveys and catch things that are this big, we get that information quality controlled, quality analyzed, and to managers as fast as possible. And that would require a lot of effort on the science side. And to your point about whether it would be as fast if it was a quota reduction, it is very hard to imagine that that would go without explosive debate in what's intended to be a public process. At most, I think that would slow it down, if not derail it altogether. But we'll have to see. Part of building flexibility in, I guess, is going to be success stories that work out for the anglers and the fishers, and maybe we'd have to see how the other direction works in time, too.
Thanks, Chris. Well, so thanks to all of our wonderful speakers today. I hope you all enjoyed the session. I know I did. I don't want to be the one between the bar and this room. But please make sure to check out the posters as part of our session tomorrow evening. And so that we can have more in-depth discussion, we also have a little event happening on Wednesday afternoon. Details are in the schedule, so it'd be great to see some of you there. And please also remember to get in touch with any of the remote participants on the app, just to keep conversations going. So thanks for attending.